book for the class as well, the Cloud Computing for Managers. Okay, just check in really quick. All right, let's get started. First, let me remove my annotations. All right. Okay, so where to start? Where do we start? We'll start with defining the term cloud computing, talk about some characteristics, talk about at a high level some of the abstractions that cloud provides. And let's talk about also like why is cloud like a thing, right? Like people would joke about how cloud is like other people's servers, right? Well, how is this different than just other people's servers? Why is cloud not considered a mainstay of pretty much all infrastructure and application deployment now? Why is that? So part of this is that there's a big push now around modernization. And as you see in most industries, whatever reduces friction, right, usually is something that gets highly adopted. Like we didn't know that we had friction with taxis until all of a sudden someone came out and said, hey, you can use your phone and call a car. And guess what? Now we can ride with strangers and we're totally comfortable with that. Versus we all had an issue with taxis. I didn't even know I had an issue with taxis until Uber and Lyft came out, right? But apparently we all had one. And so anything that reduces friction, anything that makes it easier for us to do things, especially if it's in the palm of our hand, is a transformation that we all want to in form or fashion. And cloud and digital transformation is an effort to create a reduction in friction. Whether that friction is in your organization and its inability to release applications, or whether it's an inability to craft infrastructure and keep up with environments. That's really what cloud transformation, what cloud computing does, is it reduces the friction for you to do something, whether it's deploy infrastructure, deploy a platform, or deploy a high-level service. That's really why cloud computing is taking over, is because all the great apps in the world reduce the friction by which we are trying to accomplish something. So digital transformation plays a role in this, because digital transformation is where we're not just focused on how we roll out infrastructure and applications, but we're looking to how to integrate digital technology into all areas of the business for one reason: to reduce the friction, right? We want a great developer experience so developers can just focus on delivering value, push it out, right? So what we're looking for here with our digital transformation is to make everything just a little bit more agile, flow a little bit better, a little bit smoother, right? And in some cases, these can be huge disruptions with our digital transformation. Now, there's always three components when we talk about any transformation in the digital industry. There's the people, there's the processes that we follow, and there's the technology, right? Now, we're always focused on technology. Hey, look at this, Kubernetes is out. Isn't it the most amazing thing? It's a panacea. And all of a sudden, it's going to get your people to talk to each other and be interactive, and they're going to be nice to each other, and they're going to maintain their skills, and they're going to upskill. No, it doesn't. If it did that, well, one, we're all, for the most part, the industry is chasing Kubernetes, right? Because they want that. But what they're finding is the same thing they're finding out with cloud, right? Cloud was kind of like touted in a sense as this panacea. And what we're finding is that cloud solves a lot of problems, just like Kubernetes is going to solve a lot of problems. But technology doesn't solve our people problems, and it doesn't even solve our process problems. If you're horrible with virtual machines in your data center, you're going to be horrible with virtual machines in your cloud data center. You are, right? I'm just going to say this, and you can qualify what horrible means. But if you've got friction because you can't deploy a simple Windows operating system without taking 3 weeks to do it, unless you're having a hardware problem, which cloud could solve for you, unless you're having a hardware problem, you're still going to take 3 weeks to deploy that operating system. Because if there's like handoffs, processes, because there's people, there's process, and there's technology involved in these digital transformations, and involved in almost everything that we do with the business that is focused on digital technology. So that being said, cloud is actually the foundation. It's an afterthought now. The year is 2021. First services came out in 2006. About 2010, one could argue that AWS hit its stride in being able to provide stable core infrastructure services. In 2015, they were offering amazing software as a service and platform as a service. And they just continued to do that. So is Azure, so is Google, so is IBM Cloud. So is there's a lot out there, actually. But the big three is probably what we're going to focus on. But it's now in almost every industry, cloud is either the primary platform or it's primary of two platforms that you are using to run the digital technology in your business. So it's an afterthought now. It's not even considered something that we need to be on the cutting edge of. It is now mainstream and even could be considered late adoption at this point in time. Now, with that, of course, the bottom line is that we always want to deliver technology and we always want to deliver transformation that's relevant for the business, right? At the end of the day, technology and the people and processes for technology's sake is useless. We don't work at a university for the most part. If you do, by the way, kudos, because I think that's awesome. But if most of us don't, right? We're working for customers who need outcomes. Cloud computing is a way to get to more agile, more automated, faster, more consistent outcomes. Because what we're looking for, whether you're using an agile methodology or you're touting cloud computing or you're touting Kubernetes, what you're looking for is you're looking for the ability for your business to get software with the features you need delivered consistently, compliantly, and faster, right? You want those cycles to be able to experiment, to be able to deliver faster and faster and faster. Cloud computing enables that, but it's just one component. So I don't want to overstate this and be like, hey, cloud computing is going to solve all your problems. It's an afterthought. You should learn it. Your team should know it, right? Should be adopting it by now. And it should be a core staple of what you're delivering, but it does not fit every use case either. So that's the other thing, right? Cloud computing is not going to fit in for every customer and every client. So we're going to focus on what cloud computing can provide, both the pros and the cons, and how cloud computing can fit in with your digital transformation. That's going to be our focus. But you're going to hear me talk a lot about the technology, and I'm going to verbalize a lot of caveats around the processes and the people, because I want you to come into this with eyes wide open. Now, you might be asking yourselves, well, who is this guy, right? Who is Michael Forrester? So I've been a veteran in the industry for about 25 years. I started out as an engineer, and after watching a bunch of companies fail, I started moving more and more into architecture and then into leadership. My last few roles have been as either a leader of a digital transformation initiative inside of a company, or as either the VP or director of infrastructure for a variety of medium and large companies. My last large enterprise was actually with Honeywell, where I was the lead architect for containers and cloud globally for the entire company. So I have a little bit of experience doing this. I've been all in to cloud, by the way, since 2011. And I've either been all in cloud in the company that I was at or migrating from a data center in the cloud. But Gartner, by the way, predicted that most of us would be hybridized, which means we would have a private data center and a public data center, and we would be using both in 2020, right? They did that 10 years ago in 2010. Guess what? Most of us are doing that. We've got a little bit of a data center footprint that we've maintained onto, and we're actually using our cloud footprint to expand our capabilities, right? So we'll dive into that. Okay. So then what is cloud computing? Is it just other people's servers? Is that what we're talking about? Basically what it is it's software-defined infrastructure that's easily self-provisioned, right? It's software-defined infrastructure that's easily self-provisioned that operates at three levels. You can either get infrastructure as a service, a platform like a database as a service, or it operates like Gmail and you just get a web page that allows you to interact with the service, right? You don't get to configure it or mess with it. You just consume it, right? That's software as a service at its highest ideal, right? And that's really what it is. It's software-defined infrastructure that can be evolved into those three levels. Now, this does mean, by the way, that you are going to be initiating services inside whatever cloud provider you're using, and they're going to be tied to a specific geographic location. Now, you may not know exactly where that is, but you know it's around usually a metropolitan area, and that usually has a name like Oregon or Los Angeles or Virginia. Can you go and see exactly where your data is at? No, they don't allow tours of the data center. By the way, it doesn't mean you can't go on Google Maps and still find some of these data centers, which is hilarious, but you won't find all of them, right? You won't find all the data centers, but you'll know that it's in a particular geographic area because they'll label it as such. They'll say, hey, this particular zone is in Boston. So you know that it's probably somewhere plus or minus 50 miles, either east or west, centered around Boston, but you don't know exactly where it's at. That's part of the thing around public cloud in particular. is they don't let you know exactly where your data is at. They just let you know the general area so you can get closer to your users, right? Now, when we talk about cloud computing as software-defined infrastructure that you can easily self-provision, easily consume, that you can do at 3 levels, what we're talking about is deploying our application code and deploying our data into these systems. That's what we're doing. At the end of the day, that's the only 2 functions we do, is we're either putting code into a system and configuring services around that code, or we're putting data into the system and we're transforming that data. Most of the time it's both, right? So whether you're putting a database in or video files that you're transforming through a bunch of services that, Azure has, you're either putting code in there or you're putting like raw data in there, right? And in some cases, you might be doing both, where you've put code and you've put raw data in there, and you're actually capturing behavioral data about how someone's using your service, and that becomes more data, right? More data, right? And that's what we're doing with cloud computing, is we're either sticking apps or data in there. Now, the value proposition of cloud, right, is the ability to, first of all, software-defined infrastructure means you no longer have to deal with hardware boundaries. This is kind of a joke for me, by the way, where they're like, wait, we don't have hardware boundaries? Like, for example, just to be specific about this, S3, which is the simple storage service inside of AWS, says that you are unlimited in the amount of data that you can copy up to AWS S3, right? That's a pretty bold statement, right? I was like, if I ever win the lottery, I might set aside $1 million or $2 million and just test that theory. I'm going to put a couple exabytes of data up there and see what happens. But it highlights a point, which is Amazon's not scared of you hitting their hardware boundaries. Neither is Azure, neither is Google, right? So that makes it really on demand. It makes it really scalable, right? And if you do it properly, you can achieve the cost efficiency and the business continuity that they're talking about. And if you automate it, you can achieve the accelerated business transformation plans. You can actually achieve that frictionless model of delivering software frequently of value to your users. But to get to on demand and to get to scalable requires people and processes with the skills to drive automation more deeply into your cloud computing. If you use cloud the way that you have used your traditional data center, and you don't change your model, which is your people, the way they're thinking about it, right? And you don't change your processes, and you don't shift your technology, just to be frank about this, and I'm sure Amazon would kill me if I said this, right? Is that it's just going to be expensive data center 2.0. All you've done is offloaded some operational concerns like hard drives and power and cooling. But for the most part, if you just to spin up the same virtual machines the same way that you've been using in your traditional data center, you haven't really gained anything. So part of cloud's value proposition, even as put forth by Gartner, requires us to change the way we think from a people perspective, what we do from a process perspective, and in some cases even change the adjunctive tools and technologies that we use. Because just to say this, I know this might be pretty bold, is that if you're still using virtual machines to deploy your apps today in this 2021 environment, if you don't have a stringent hardware requirement to do, like a software requirement to do so, you might want to look at that, right? Because now we're using containers and now we're using serverless to deploy our apps. And those are 2 models of hosting that work well with virtual machines, but they are far more efficient if done properly than virtual machines ever will be. So that's probably the value proposition of cloud, is you get to move and elevate your digital transformation through these technologies by modernizing your application. So what are the advantages? 1, stop dealing with hardware, right? You stop dealing with hardware. That's one huge advantage. By not dealing with hardware anymore, by just dealing with virtual machines and not having to run cables under the network and having to buy servers and wait 6 to 8 weeks for them to come, you get scalability and reliability that Amazon's and Azure's and Google's world-class infrastructure provides. Now, don't get me wrong. We know these companies have outages, right? But considering the size that they're operating at, are their outages more frequent than your outages in your data center, right? The other thing with that is that you don't necessarily have to sign a contract. You can literally set a credit card down and get global scale in just like 15 minutes, which is kind of crazy. The other thing though is that if you want cheaper, you don't want to pay on demand, you don't want to slap a credit card down, you can actually get into a very loose contract or relationship with all three of the big providers at least, and also a lot of the small ones. And you're only paying for what you use. This is utility computing. Meaning if someone comes to you and says, look, I need 10 virtual machines, you're like, are you sure? And they're like, I didn't really know. You know what, let's buy 20 virtual machines of a size. And then after day one, if we find out we only need 8, guess what? We're gonna give the other 12 back. What did that cost us? Nothing. You didn't have to buy hardware that you can no longer give back to the vendor. You purchased software that was on demand. And if you didn't need all 20 units, you cut back to 8 and it was totally fine. That elasticity is a huge hallmark of cloud computing. That pay-as-you-go model, right, allows you to only pay for what you're using. Now, that fourth bullet says pay-as-you-go lends transparency to your cloud business. I can't tell you how many conversations I have with people, engineers, right, who set up infrastructure, and they're like, AWS is so expensive. I was like, yeah, that could be true. It could be more expensive than what you're doing in your data center. I'm not saying it's not. Most of the time it isn't, by the way. Why do you think it's more expensive? And they're like, Amazon charges me for pulling data out of the cloud. They also charge me for like networking and stuff like that. I was like, well, do you know how much that costs in your data center now? And they're like, no. Well, then how do you know it's more expensive? If you don't know what your power, your cooling, and your networking costs on a per server basis, how do you know that it's more expensive than what you're doing now? I'm not trying to create FUD. I'm just saying that you don't actually know, right? Amazon will tell you, Azure will tell you, Google will tell you every single nickel and dime thing. And you're looking at that and you're going, oh my God, it's so expensive. It's like, have you ever stood up a data center and bought like a huge power cooling unit and bought a bunch of core network switches and had to do that whole thing and lock down physical access and paid for security guards? The point to all that is that sometimes that transparency can seem overwhelming, but that transparency, particularly around billing, which is one of the hardest topics in cloud, will allow you to see exactly what it is costing you, and you can probably extrapolate what's going on in your data center as a result. But that transparency allows you to see the value of the pay-as-you-go model. The other piece of that is that because you can go global so fast, right? One of the things that will enable that globalization, right, the ability to basically run multiple regional data centers the world over, is that you're going to need, right, the ability to be development and operationally agile. But software-defined infrastructure enables that. Imagine you don't have to run cables under the floor anymore. You don't have to wait to rack new servers. Cloud inherently enables more agility because everything is software-defined. Right? You want to spin up a new VPN connection between your corporate site and AWS? Guess what? That can be predominantly automated. The only thing you would need to mess with manually is the configuration settings on your site side, right? You want to spin up 1,000 servers? That's easy, right? Just make sure that you don't have any service limits that prevent you from doing that, but you could spin up 1,000 boxes. You want to spin up 2 databases in 2 different regions of the world? That's a couple of clicks. That kind of operational and developmental agility can just not be beat, right? And so cloud computing naturally enables that. And I would argue, by the way, that cloud enabled DevOps. It actually enabled Agile to a large degree when it came to infrastructure. Because before, we were provisioning until we ran to a hardware boundary, and then we were waiting 8 weeks to get more hardware. Hardware boundary, more hardware. Meanwhile, while that was happening, our customers were suffering because we didn't have the performance capacity to keep up with demand, right? That's gone. Cloud nixes that. Now, can that come at the cost of being like more expensive? Absolutely. But that's only if you're not very precise with how you're matching customer demand. And if you over provision, that's when the value of these cloud providers is greatly diminished, when you're trying to think of it the same way that you thought about your old data center. So these are some of the advantages. Not necessarily signing a contract, which you can, but you basically avoid CapEx, capital expense, lot of scalability and reliability if you use AWS correctly or Azure correctly or Google correctly, right? More business agility because you focus less on running good infrastructure and what's core for your business, which is probably your applications, I'm assuming. A pay-as-you-go model that really lets utility computing shine. You only pay for what you need, give back what you don't. If you need more, you can get it, right? And then global reach, which allows you to go global in seconds once you've had your account stood up, right? And then more operational and developmental agility, because you're no longer fighting with hardware boundaries. Everything can be defined as an API. Everything's a software object. So now you can literally just programmatically stand it up as you see fit. Good. And this, by the way, this slightly pixelated slide, everything being so high resolution now, right? Shows that basically what we did before is we bought servers, we had demand, and every time we got close to saturating demand, we bumped up a level. We just kept bumping it up. And so you can see that stair stepping where it's like, we got to do a large capital expenditure. I cannot tell you how many times I would sit with the CFO and he would say to me, do we really need to spend $200,000 on hardware? And, you know, like dumb, arrogant engineer. I'm like, well, I mean, you know, if you want to avoid an outage, right? And it's like, that's probably not the right answer. But at the same time, it was the answer, right? It wasn't I was trying to scare him. I was like, look, we're running out of capacity. With AWS, by the way, this changes slightly. Instead of one big stair step in which, by the way, if demand goes down, you're still paying for hardware you can't return. It's not like you could go back to Dell and be like, hey, Dell, I know like I spent $200,000 on servers, but I'd like to get $50,000 of them back. Can I do that? Dell's like, well, we might take them at a reduced cost, but you know, we'll give you $30,000, right? Typically, unless you had just an amazing relationship with your hardware vendor, they're going to do that. AWS, that shifts. It's exactly as I described. You need to start a 10 terabyte MySQL database for an hour. That'll probably cost you, by the way, $2, right? To run it for an hour at 10 terabytes. You want to run that for an hour? Great. You're done after that hour, give it back. You don't have to worry about like retaining a MySQL license or having to figure out where that hardware is going to live. All that's done, right? You all of a sudden get a surge of traffic because your site suddenly became popular on Reddit. You need to add 100 web servers to your web server pool. Do that. When you're done, give the 100 web servers back. Maybe it only lasts for 24 hours. So multiply 100 servers times $2 an hour, right? Times 24 hours. And you just surged to 100 web servers, right? For about $4,800, right? You might think, wait, $4,800? I don't think you can even buy an 8-core system with 16 gigs of RAM for $5,000, right? In cloud, you can get 100 of them for 24 hours to give them back when you're done. So this really allows us to provision without having to do these large capital expenditures, right? Now, don't get me wrong. This is software-defined infrastructure. So if you just give your entire company access to this, you will probably be spending some money that's probably very inefficient, right? So you do have to come out with a strategy. You can't just like wide open and say, look, everybody have cloud. I was at a company that will go unnamed where that when I walked in, that had been happening for 18 months and they were spending $25 million a year. Now, don't get wrapped around the number. That could have provided $100 million of value. By the way, this was $1 billion company. That could have provided $100 million of value. The problem is that nobody knew, right? Who cares that they were spending $25 million? The problem is that they knew that probably about maybe $10 million of that was completely waste because they had just wild west that opened up their cloud computing environment and said, guess what? You guys can all do what you want to, right? But that would be true for your infrastructure as well. If all of a sudden you were like, hey, everybody can just deploy onto our infrastructure and do whatever they want to. So again, it's not a panacea. Your bad habits that exist prior to cloud will exist when you go to cloud. But there's tons of benefits if you can learn how to manage cloud correctly, where the value goes through the roof. Cloud providers by default do follow a shared multi-tenancy model, right? It does require the use of virtualization technology. So we are talking about virtual machines. We are talking about containers. We are talking about serverless to host our applications. But they also do shared abstractions for storage, shared abstractions for machine learning, shared abstractions for networking, right? But everything, by the way, is focused on security, right? Just to say this, because the number one objection to cloud back in 2006, 7, 8 was security. Why would I ever give a third-party vendor my data? They could use it, they could see it, someone, an internal employee could take it and hack it. To date, by the way, notwithstanding all the craziness going on with Microsoft, right? With Azure and with Exchange and all that, right? But to date, an internal employee hasn't necessarily like taken that data and done anything with it. I'm not saying that, like, for example, Microsoft's little disaster they got going on right now doesn't have external hackers going in and messing around with their infrastructure, right? And again, I don't even know what the impact is against Azure other than an outage, right? But like, data hasn't been stolen, right? Now, don't get me wrong. People have put data in cloud, opened it up to the internet, and said, huh, I wonder what happened there. Someone stole all my social security numbers off of my public website. It's like, well, yeah, that's probably a configuration problem there. But just know that the multi-tenancy model actually makes the cloud providers very sensitive to security. And for example, if you're using if you're using AWS S3 and you try to open your S3 bucket out to the world, because these things show up in the news all the time, you have to say yes like 3 times to like, are you sure? Are you sure you want to do that? Are you sure you want to put all your stuff out on the internet? Because that's what you're saying yes to. You have to do that a couple times, and that's on you, right? That's on us. We're the ones who have done that, right? But the multi-tenancy model is prevalent for cloud providers. But I will say this is that all of them have a scenario where you can actually get dedicated hardware that's just yours and nobody else is on that hardware. You can literally, for example, buy bare metal systems through these interfaces like the console or whatnot that have nothing else on. They don't even have a hypervisor. You can install your own hypervisor if you want to into these systems. So while it's true it is a multi-tenant model, there are services that are single dedicated tenant, like key encryption, by the way, can actually be done through a hardware device that's single tenant. Nobody else gets to have access to it except for you. So there are single tenancy, dedicated tenancy models as well. Now, the National Institute of Standards and Technology says cloud computing is the model for enabling ubiquitous, convenient, and on-demand network access to a shared pool of configurable computing resources. That's a pretty good definition. That can be rapidly provisioned and released with minimal management effort or service provider interaction. That's a great statement. And that's true, actually. In the old days, we had to go down, have a lunch, sign a contract, put the contract through legal, right? Probably remember those days. You're having to negotiate, right? You got the contract signed, legal approved everything, and then eventually you got access to your hardware resources. Those days are over. Credit card, 15 minutes. Either click through the console, click through the command line, or define it programmatically, and you can have all global reach of web servers within 15, 20 minutes. So from this perspective, let's talk about the cloud model and the 5 characteristics, the 3 deployment models, service models and the 4 deployment models. We've touched on these just a little bit already. All right, so here are the 5 characteristics. 1, it must be self-provisioning, must be on-demand self-service, meaning you need to be able to automatically register yourself for account, go through some kind of automated verification, and then get access to services and services within a certain limit, right? AWS, by the way, does put service quotas on the amount of virtual machines and the amount of stuff that you can do so that you don't like hurt yourself financially because someone put 2 zeros in a configuration file and all of a sudden you got 5,000 boxes. You can't even start 5,000 boxes without talking to Amazon for like, or Azure or Google for half a second saying, hey, by the way, can we raise our limits? And you don't have to talk to them, by the way. There's also a console you can use to raise your limits as well. But all that's configurable, but it is on-demand self-service, but they do actually take steps to prevent you from hurting yourself financially, just FYI. You also need broad network access. For these cloud providers, they have easily multi-terabit connections to the backbones of the internet. Network bandwidth is typically not something that you ever worry about when you use these cloud providers. You're never worried about them running out. Resource pooling. So Amazon, as an example, just cut the prices for their archival storage. I want to say by like 10%. I can't remember the exact number. Because of that, by the way, it's now 1/7 on average compared to their standard storage model. Why do they keep cutting prices? They keep cutting prices because they're pooling resources and they're getting more efficient at it. So it's getting cheaper and cheaper for them to add servers because they're getting huge economies of scale. And all the providers usually pass that back to the customer and say, you know what, your storage just got like 10% cheaper. 2 years from now, it'll get 10% cheaper. 3 years from now, it'll get 10% cheaper. And it just keeps going down so that the price per gigabyte keeps lowering and lowering and lowering and lowering, right? The other piece is that number 4 is that there's rapid elasticity. So you can go in and provision what you need. It's over a fast backbone. You get economies of scale, so you get to pool resources and share multi-tenancy, but your performance is guaranteed. If you ask for 2 cores and 8 gigs of RAM, you're going to get 2 solid cores of processing power, and you're going to get 8 gigs of RAM. If it says it has a 40 gigabit backplane for that server, you're going to get 40 gigabits. You can run 40 gigabits through that whole thing. But the other piece is you can add and expand your services as you see fit. So if you need 20 virtual machines, 30 virtual machines, you need to add numbers, you can do that, no problem, right? Now, the other piece of this is the measured service. They are one of the characteristics for all of these providers is that they are looking granularly at your billing, and they are sharing that granularity of billing with you. But I want to say there's 2 things that are harder in cloud. One of them is security, just because it's not a model that, not that because they're not good at security, but we're not good at security yet in the cloud. We're still evolving that. But the other piece is billing, right? Understanding your billing and being able to see that is one of the key characteristics they provide, but it's one of the hardest challenges for us to really understand, especially for large enterprises. Now, those are the 5 characteristics of cloud: the self-provisioning, right? The broad network access, the resource pooling, the rapid elasticity, and the measured service. Let's talk, we mentioned the models of delivery already, is that services available across all the providers are either going to be infrastructure as a service, which means you've decided to get virtual machines, right? Or you've decided to have base networking access, or you've decided to run a platform like a MySQL data store or a Microsoft SQL Server data store or an Oracle data store, like database, and you're not interested in the operating system. You just want access to the platform itself, right? You don't care what's underneath it. You just want access to Oracle, right? So that's your application, but it's not Gmail. You can actually go in and configure the database, but you can't mess with the operating system. That's a PaaS. That's a platform, right? And there's a very broad definition, by the way, of platforms. You can go even a little higher than that. But then there's software as a service where you're saying, look, I'm going to give you my code, and I just want you to run it. I don't want you to do anything. I don't want to mess with servers. I don't care what the run times are. I don't care what web server you use. I'm going to give you my HTML and just run it. Don't talk to me. Just run it. I'm going to answer a few questions and go, right? And that's software as a service as it relates to cloud infrastructure. And those are the 3 base models. But we're used to these models because we use these models all the time for other things. Like we know that Gmail is a SaaS, right? Oh, we already talked about this. So infrastructure as a service, by the way, I mentioned is virtual machines, which those are all different flavors of virtual machines. PaaS, excuse me. This would be, by the way, orchestration of those virtual machines. So they're abstracted in for example, the installation of databases, graph databases, Elasticsearch databases, machine learning, notebook workbenches, right? And then SaaS, of which, Salesforce.com would be an example, or the Creative Cloud for Adobe, right? These are all just web page services where we're just consuming the feature. We don't have to manage it or configure it in any way. So when we think about this, right, infrastructure as a service is the lowest level, but you get the most control. Platform is a compromise where you're kind of like sandboxed, but you have some control, but you don't have total control. In SaaS, you have no control. You can configure some things in the service, but for the most part, you can't do anything other than use the service, which is what SaaS is mainly for. Like Gmail, for example, as an example, you can go in and configure some things for Gmail, but you can't go in there and change the mail server or change the operating system. Those are all abstracted away from you. So There are, by the way, lots of partnerships. Red Hat has partnerships. Salesforce has partnerships. SAP has partnerships. Everybody's partnering with cloud now because everybody wants their stuff on cloud. All three of them, by the way, the major cloud providers have a marketplace where you can go and find the vendor. Are you dealing with TIBCO? Guess what? TIBCO's out there. You dealing with Checkpoint because you love the firewalls? Checkpoint's out there. Now, don't get me wrong. You can actually have a relationship with the vendor, license it, and then deploy it on the cloud. Or you can go into the marketplace, grab the vendor's image or service. They will charge you not only the cloud resource, but the licensing fee for the resource in question for the vendor, and you can just deploy it out on AWS. You don't even need to talk to the vendors anymore. You can go grab a Checkpoint firewall right off of the, for example, the AWS marketplace, and you don't even need to talk to anybody. You don't need to talk to anybody at Checkpoint if you don't want to. There's so many partnerships, it would be hard to talk about. Like VMware, by the way, is actually partnered with almost all the, I think all three major providers. Red Hat is partnered with all three providers. Even Microsoft, like AWS and Google still run the Windows operating systems. MS SQL Server, which is the Microsoft database, that still runs in Amazon and in Google, right? So options. One piece of this though, because I said that billing and security were hard in cloud. They're the harder topics. They're not hard. They're the harder topics, right? One of these is this shared responsibility model because the three deployment models, the three models of service, right, actually have implications around security. Here's the deal. With the infrastructure as a service, because when you're on premise, you're responsible for everything, right? But when your infrastructure is a service and you decide, for example, to start a virtual machine, the only thing that you're responsible for is everything from the operating system up. Meaning you have to patch that the operating system for that virtual machine because you asked for it, and Amazon's not going to manage it for you because you said, I want an operating system. I want a virtual machine. It's got an operating system. And so you're responsible for the configuration of the virtual machine, patching the operating system, and any software or data you stick on there. If we move one to the right and go to platform as a service, what changes is that you no longer have access to the operating system. As a matter of fact, you can't uninstall or install the platform. It's chosen for you. So your runtime's done. But if you stick data in that system or an application into that system, that security is on you. You have to check the boxes to secure the data, and you need to make sure that your application doesn't have any kind of inherent vulnerabilities that can be exploited. And then if you go all the way over to software as a service, if Gmail gets hacked, because that's our example of software as a service, that's not your responsibility. Oh, now if you put your password in as your birthday and your first child's name, that's on you. Okay, that is. I have this conversation with my mom all the time. I'm like, Mom, can you please change your password from what it was in the 1980s when we didn't even have these kind of services? She's like, what do you mean? And then I rattle off what her favorite number is. And she's like, how did you know? And I'm like, Mom, it's been the same thing for like 40 years. And so if I know it, by the way, all the hackers on the internet know it as well, right? Right. And so that's software as a service. So the only thing you're responsible for is the things that you can configure. Typically, that's your password and a few configuration settings. That's it, right? But the thing that changes is that with infrastructure as a service, you have more security responsibility. PaaS, you have less. Software as a service, you have very little. So everything else in blue is the responsibility of the cloud provider. That's called the shared responsibility model. And so these three deployment models that we were just talking about have implications for your operational overhead for security. If you're doing infrastructure as a service, guess what? You're responsible for a whole lot of security. If you're doing software as a service, you might pay more, but that also means that you have less operational overhead overall, but particularly when it comes to security. So just something to keep in mind. This is why, by the way, when I talk to people, I'm advocating try to get away from virtual machines because you've got a tremendous amount of overhead with virtual machines that you won't have with containers, and you're really not going to have with serverless. So try to evolve your apps towards less footprint. Yeah, I know not everything fits into a container. Well, that's not true, actually. Anything can fit in a container, doesn't make sense for it to fit into a container. And certainly there's strong limitations for serverless that apps are not going to run in serverless. There's more limitations there, right? But try to make that step in that evolution. You will reduce your overhead, increase portability, and reduce your security footprint all in one fell swoop. And that's just these three models here. Okay. So if those are the three service type definitions, and there's 5 characteristics, right? We talked about 5 characteristics, right? The self-provisioning, the economies of scale, having broad network access, right? Being transparent billing and elasticity. Those are the 5 characteristics we talked about earlier. We talked about 3 models: infrastructure as a service, platform as a service, and software as a service. What we've got here is 4 different deployment models for cloud. Now, what's funny, by the way, is one of these you don't ever see hardly, like, that's a lot of qualifiers. You don't ever see hardly, horrible way to say that. You don't really see them unless it's the scientific community, right? Which is community cloud. The others, private cloud, public cloud, and hybrid cloud, we know about those. The public cloud providers are the public cloud. Our data centers are the private cloud. And if we connect the two together, that's a hybrid cloud, right? Because we're using both, right? The community cloud is a little weird because you don't see that except for like universities or like consortiums of where basically you've got like 5 universities who all pool their resources into creating their own private like data center, but it's not owned by one university. It's owned by like 5 or different universities. There are other community clouds like manufacturing clouds where you got 5 manufacturing companies who have all banded together to create their own private cloud, but that's really the distinction. Community clouds are rare. Public cloud, private cloud, hybridized cloud, those are very common deployment scenarios. Most of us in 2021, if we are an established company, are using hybridized cloud where we have a private footprint and we're hooking into a public footprint. Just to say this, every single startup, dozens that I've either reviewed, evaluated, or even talked to in the Atlanta market, particularly because there's this place called the Atlanta Tech Village, this is like an incubator for startups, they're all cloud. None of those guys they're not using any data center, they're not rolling their own hardware, unless I have one because they have specialized hardware requirements and they have to. Every single one is using either AWS, Azure, or Google, right? So just think about that, because that generation of startup leaders are going to be the next generation of leaders, right? They're going to rise through the ranks and they're going to be the people who show up, as the CEOs and the CFOs over the next 20 to 40 years, right? And in their world, they were never in the data center, right? They don't even remember, for those who've ever been in the data center, they don't even remember the loud hum of the turbines completely dominating all sound and white noise. They don't remember that. What they remember is that they could write some code and start up a virtual machine and deploy their application, right? So hybrid model, even you're seeing now, is actually getting smaller and smaller. And you've got people who are all into public cloud, or they're all into multi-cloud, right? Which is kind of our new deployment model. Let's spread the love, at least between 2 and 3 cloud providers. That, by the way, comes with its own headaches. So, which we will touch on. Now, here's the other thing that's a little weird about these deployment models. All of the 3 major providers now have the ability to run their infrastructure in your data center. Let me say that again to make sure that sinks in for a second. Azure has Azure Stacks, so you can actually run a piece of Microsoft's hardware in your data center, and it hooks into the public cloud. Did I just freeze? Oh yeah. Amazon has Outposts, which now allows you to now take a piece of hardware, put it in your data center, and it hooks into Amazon's cloud. Google's Anthos program it's kind of cool, actually. It's actually a virtual machine that you can run anywhere in the world, and it will hook into your Google infrastructure. By the way, you can run that virtual machine on Amazon or Azure and hook your virtual machine into Google's infrastructure. That was a genius play by them. Google sometimes does some really cool stuff. Otherwise, they're honestly a little strange in the cloud environment, but they've got a good product. So you can actually literally get your public providers to run in your data center, and that's not really hybridized. That's them just encroaching into your data center. So if we look at that model, Azure has obviously the public cloud, which is just the Azure piece. They've got hybrid cloud with stacks. By the way, they're the only provider that makes their own operating system. So they're the only ones that really run in private cloud. Don't get me wrong, Amazon has like Amazon Linux, but they don't support that. They don't offer it as a product. I don't think Google has an operating system, right? Microsoft is the only one, by the way, who has the Windows Server technologies because that's a pre-existing product. So they actually run in the data center. By the way, who's the biggest enterprise virtualization provider inside the data center? Does anyone know? Because it's not Microsoft. Want to know off the top of their head? To date, it's VMware, right? VMware is the biggest provider of enterprise class virtualization software, along with Red Hat, right? In the data centers, right? Red Hat and Windows vie for domination of the operating system. Red Hat and VMware vie for domination of the virtualization space as well, from an enterprise standpoint. Don't get me wrong, Hyper-V is there. There's tons of other open source projects like Zen and stuff like that, Citrix Zen Server, for example. But really, VMware and Red Hat dominate the virtualization space. Now, I got an interesting question. Do you think that SMBs who start with 100% cloud will stay 100% cloud 10 to 20 years down the road when they are enterprise scale? So I'm going to answer that question by saying this. Someone who starts 100% cloud now, if they continue to grow to scale, then I think they'll follow the model of almost every other provider. But let's use Netflix as a good example. Netflix was 100% all into AWS. And then what happened? They reached a certain threshold. Plus, they got really skilled, right? Because they were one of the first to use cloud. So their skill level is super high from a digital native standpoint. And they kept their command and control infrastructure on AWS because they wanted that resiliency and that reliability. But most of their heavy lifting is actually done on their own infrastructure and hardware, usually located in ISP data centers. So when you actually go to watch a video and you're on the Comcast network, you're actually hooking into a Netflix server that's sitting on the Comcast ISP span. Like they've made an arrangement with Comcast and said, hey, we want to put a caching server basically that can run videos because we want to take the load off of your network so you don't have to go back out to tier 1. And we're going to run our infrastructure right there in your data center to get most of your metropolitan subscribers so that you're not basically crushing your bandwidth back to us, right? Because we know this, that after like 9:30 or 10 p.m., what is it, like 17% or something, 20% of the traffic across the internet is actually Netflix? Something ridiculous, right? So when Netflix said, hey, tier 1 providers, instead of you guys having to crush your connection to the internet, why don't we put caching layers, hardware out in your ISP data centers, and in exchange, we'll save you tons of money on bandwidth, right? So looking at that model, I would speculate that there is actually a certain threshold where running your infrastructure on somebody else's infrastructure like AWS or Azure or Google is not cost effective. Not all of it, right? So in Netflix's case, what they did is they kept their command and control infrastructure, all their other stuff out there, and they took all of their heavy lifting video streaming and they took that off. Now there's still some on there and they can actually burst the cloud if they need to. But to answer that question, they're still in cloud, but most of their actual orchestration heavy lifting is actually outside of cloud now. So I think that if you start with cloud, if you achieve a certain scale and your use case allows it, you will try to hybridize as much as possible because it's going to be more cost efficient for you to get out of AWS than to put those costs into AWS or Azure or Google, right? So that's my speculation, just following the models of like Netflix. But I know of at least 10 other companies who've done the same thing. Not video companies, but who've decided to get out of the AWS infrastructure because the value was awesome, but they could make more money if they rolled their own instead of relying on AWS's infrastructure. And that was the driving line for that, by the way, is efficiency, right? As far as like being able to reduce operational overhead. Still valuable, but that's why they needed to do it. No worries. Okay. Okay, so there it is, all on one little beautiful pixelated little image, right? About common characteristics, essential characteristics around elasticity and transparency on the measured service, on demand, the 4 different deployment models, of which, remember, community is very rare. Public, private, and hybrid is very common. By the way, the only companies that I find now that are all private, which I don't mainly deal with, because I'm actually a cloud specialist, although I did a lot of work in the data centers back in the 2000s, are companies that, you know, are 50, 60, 70, 80, 90, 100 years old. Like, they've been around for a long time and they've got a large investment in private cloud. I will mention that from a business perspective, since I do a lot of digital transformation as well, those companies are struggling to figure out what their next set of relevancy is to consumers, right? So, yeah. So, you know, disruption is a big, evolution is a necessary thing for companies to survive nowadays. Yes. Just to mention this is that the slides should be provided in an email. It actually comes in a zip file. There should have been a link, that probably the same email that sent you a Zoom invitation. It has the link in there to these exact slides as a student guide. It's in a PDF, it's protected. Okay. This, by the way, is a lie. Why? Because it's 3 years old, right? It's 3 years old. I mean, that might as well be 21 years if you equate internet years to dog years, right? Right. I mean, just to say this, a year is a long time in an internet space. So I usually think of like every month and a half is about a year inside the internet. But what this shows is it shows cloud market growth and segment leaders in the first half of 2019, right? And notice, by the way, it shows, you know, Amazon and Microsoft and Google as a cloud infrastructure service at the very top rubric. And then it shows other cloud services like Ring Central and Salesforce and whatnot. But the main thing it's trying to show is that cloud market growth has been massive. By the way, does anyone know, just to pick on Amazon, because I like to pick on them, what their like annual revenue is now? We know what their annual revenue is. Just take a guesstimate. They are indeed the cash cow, by the way, for Amazon as a whole, AWS in particular. But if you wanted to know, just so you know, just AWS alone, sorry, they're at 50 something billion, 50 billion in annual, right? And a large degree of that, by the way, is profit for them. I can't remember what their operating expense was. I want to say it was like $14 million or something, but that's a ridiculous ratio of profit, right, to operating expenses. And by the way, they keep growing somewhere between 20 and 40% at minimum year over year, right? Now they're going to run into some kind of limitation at some point in time, right? Because, you know, it doesn't solve everything. You can only have so many customers, it's only so much of a pool. But the market itself is estimated to be over $1 trillion in cloud, easily, right? So this is a market, by the way, that is just honestly kind of getting started, not from an infrastructure as a service perspective, but from a software as a service perspective, right? The ability for me to just give you code and let you just host it and run it, that's the market that's going to be the biggest evolution inside of AWS, particularly for this year. Because, you know, with Edge and IoT and all those other pieces, like, we're looking to expand the footprint of, or the reach of cloud computing across the entire world. But the other thing is that we're trying to reduce the pressure on businesses and developers to deliver code by coming up with these low code solutions, or even in a sense, we're back to like WYSIWYGs, where we're trying to drag and drop code to be able to build applications. We're not there yet, but there's lots of potential in that space. And particularly where you look, where AI is now writing other AI, like we've got, you know, AI algorithms now writing their own versions of themselves 20% faster every time. What we're going to see is you're going to see more of an invasion and an explosion of cloud computing into all of these edge cases, but you're going to see the sophistication of cloud go away from infrastructure and more towards code and how to therefore provide applications. So this segment is just going to continue to grow. They're finding new and better ways to actually reduce friction in a lot of different scenarios. Okay. Disadvantages of cloud computing. Okay, here's what this should say. If you don't know what you're doing because you don't know the environment of cloud, then you're going to be at a disadvantage. You can't just treat this as another data center. Security is going to be a problem. right? Reliability is going to be a problem. You can't just assume that you know how, and they do function slightly differently. Like Google, Azure, and AWS all do virtual machines just slightly differently, right? Don't worry, there's convergence and homogenization happening because they're trying to stay fiercely competitive with each other. But you've got to learn how cloud functions. It's not like your data center. You think, oh, well, it's virtual machines there. I run virtual machines in my data center. It's fine, right? No, it's not actually. You need to have at least some awareness and some of the skills necessary to understand how the model operates, to be able to use it in a value-driven way. So security is harder inside a cloud because our models have all revolved around private data center. Understanding how we can secure cloud, how we can create zero trust networks, how we can protect ourselves in a cloud environment is something that we're still actually learning, especially as these services evolve. Vendor lock-in is a real challenge, but just to say this, vendor lock-in is a problem with every tool, right? If you decided to choose your operating system, you've got vendor lock-in. Do you know how hard it is to switch all your tooling away from Windows over to Linux for like Red Hat? Let's pick on Linux for a second. If you're in the Debian world and you're used to Ubuntu, there's little like things that you have to do to change over to Red Hat's world, to go to CentOS or RHEL or Fedora, any of those flavors, although you probably just run RHEL, just to be honest. So vendor lock-in is a problem. Here's the other issue. The deeper you go into software as a service versus platform versus infrastructure, the more that vendor lock-in grows. But here's the problem. The value is in the SaaS and in the PaaS. The value is not in infrastructure as a service, but infrastructure as a service reduces vendor lock-in, right? Because if you're just running virtual machines everywhere, then you just manage virtual machines. If you're running containers everywhere, you just manage containers. But if you're learning how to specifically deploy your software into a software as a service, they're very different across the three providers. And so your vendor lock-in is a little bit higher. But that's not really the question. The question is that do you trust and have a good relationship with the provider? Because they're not going to hurt you on costs. Why? Because there's competition in the market. If one of them was vastly more expensive than the other, no one would use it. And it would be worth migrating away from that particular vendor. So vendor lock-in is a challenge, but you've got to weigh that against what the benefit is to your business and what the risk is to your business. But vendor lock-in is a challenge, especially as you operate at SaaS. It can be a big problem. Most people's answer to that last issue, by the way, is to go multi-cloud. And to date, I have not seen a good implementation of it. How do you pick where you primarily host your implementations, right? Do you put most of your virtual machines on Google, or do you put most of them on Azure? How do you support both ecosystems, which are rapidly changing? Most of your teams can barely handle one rapidly changing ecosystem. Now I got to track Google and I got to track Microsoft. What happens when they do little tweaks like change the way their hard drives function? Do I then change it for Azure, but I don't get to change it for Google because Google hasn't caught up yet, or they don't think that feature is important? Then what happens is you start getting feature disparity between your underlying infrastructure, all kinds of issues with that, right? Until we get to a homogenized abstraction layer that can sit on top of these cloud providers that allows us to deploy apps, then we're going to have a problem running multi-cloud. What's most people answer that? Kubernetes, right? You might be saying, well, Michael, what's Kubernetes? Kubernetes is a container orchestration platform. It's relatively complicated in the world, but it's a software that sits on top of the operating system that allows you to deploy containers on it. And if you write a deployment file for Kubernetes and you've got one in Azure, one in Google, and one in AWS, then you can run that deployment on any of those providers, right? But I make that sound like a panacea that has its own level of complication. And Kubernetes is difficult to learn compared to like standard virtual machine virtualization. It is, because it's just an unknown. It's not a common thing yet. But we don't have a good answer yet for the vendor lock-in problem. And quite frankly, the multi-cloud strategy is a horrible thing to do, in my opinion, in 2021, because we haven't figured out how to come up with a really great frictionless abstraction layer that can sit on top of the cloud providers and just deploy applications, right? That's the problem. So no good answers there yet, but I'm hoping one day here in the next year or two to be able to say, yeah, you know, a company came out with this really great way to do multi-cloud, because thus far I haven't seen a good implementation, especially not at enterprise scale. I'm probably not going to run through cloud roles Don't be offended. You have this in your documentation. There are so many job titles associated with cloud, everything from cloud engineer, DevOps engineer, SRE, data, like all of this, like this doesn't, these are not clean ties in to cloud roles, right? Some of these roles existed before cloud came along. So just know whether or not the person's working on cloud or not doesn't have anything to do with their title, has everything to do with what your project requirements are, right? But this is in your handout, your student guide if you need it. Okay. We went through a lot just now, didn't we? That's about an hour, right? We went through everything from digital transformation, all the characteristics, right, of cloud, basically the self-provisioning, the broad network access, et cetera. We talked about the 3 infrastructure as a service, platform as a service, software as a service. We talked about public, private, and hybrid cloud, along with community, which is that mythical kind of 4th model of deployment. We talked a little bit about market growth and some caveats to think about around cloud. And then the last thing that we talked about was just the disadvantages and some of the pros of cloud computing. Okay. So we're going to roll into this next section. But before I do so, who has questions? All right. I was worried actually that the chat wasn't working and that I wasn't getting it. And then I started getting a bunch of messages. So now everything's working good. Excellent. Okay, we're going to keep going. Just know that since we started at 12:30, right about 2 o'clock, I reserve the right to stop right in the middle and for all of us to take a biology break. It'll be good for your brains. You'll remember more about what I'm saying. But we're going to take a little bit of break around like 2 o'clock in about 30 minutes. So I'm just giving you fair warning. Okay. This one's a little bit of an eye chart. Basically what it says is that Amazon was in the lead. Microsoft is a close follower. Google's next, right? Which is probably pretty accurate. I would probably say now, by the way, because I think this was in 2020, is that Google is actually probably not third. I know that like most people are like, what? Google's probably not third, honestly. Alibaba Cloud is probably actually third, or the IBM Cloud is probably third, and not the Google Cloud. I'd have to look at the 2021 statement around that. But like this is as of 2020, but there I've seen ones where it basically Google's like barely in the leaders section because Google was messing around for a while and I'm not sure exactly what they were trying to compete on, but they weren't really staying competitive with the rest of the services. That being said, mindshare wise, it is definitely AWS, Microsoft, and then Google, right? No one thinks of IBM Cloud. No one cares, right? When I talk to engineers, they're like, hey man, IBM Cloud is awesome. I've never heard that statement. Everyone's always talking about AWS, Microsoft, and Google whenever I get like do presentations or talk to students. Like no one, it's like IBM is the best. And don't get me wrong, their acquisition of Red Hat was awesome. That you think they get more mind share, but people are more concerned about what IBM's doing to Red Hat than Red Hat actually taking over IBM. So yeah. So this is probably still somewhat accurate, but there's probably some question about Google's role in there just yet. I think they've made a stronger showing in the last 6 months, but they were messing around there for a while and you weren't really sure what they were doing. Now, what did I say were the 2 things that were harder, billing and security. So to that end, inside the document, there is the pricing calculator, the Google calculator, and the Microsoft Azure calculator. Just to show this in action. Thanks for pulling that onto a second screen. This, by the way, is a calculator, which is a little bit of an eye chart. So I'm gonna blow it up so you can see it, right? On the left-hand side, we've got services. Yes, unfortunately, you'll need to know what these services do. And they don't come with an easy forward guide. I've literally been tempted to make a poster that has Azure, Google, and Amazon services, and in 4 words or less, I would describe what they were. Virtual machine service, right? API-driven storage, like just to give you an idea of what they do. Regardless, the EC2 service, which is the virtual machine service, if you wanted to come in here and do costing, you could come in here and choose one machine that's used 24/7. And then you could come in here and choose the size. Now, this is where things get overwhelming. There's a lot of options for size. But by the way, this column is processor and this column is memory. And all of these things mean something, which I'm not going to explain because, quite frankly, it's not super relevant. But let's say that we decide to do the Gravitron processor and I want a 2x4 machine with its own dedicated storage. Notice my bill has changed to $56 a month. It's going to cost you $56 a month to run that system with no special attached storage. If I want to attach like specialized storage to it, I could come down here and say, look, I want a 0.5 terabyte of storage and I want the latest generation of storage. And now my bill up here has gone up to $100 a month, right? That's for a 2x4 fully redundant enterprise system with the operating system licensing and everything taken care of, right? So this, by the way, you could add a bunch of systems in here. You could actually specify by region. You could change the billing model if you wanted to. This is just an example, but most of the services are listed here. AWS, by the way, also has what's called a new pricing calculator available as well. So this one doesn't yet have feature parity with this one, the link that we put into the document. But just know that if you go to calculator.aws, which I actually will post in chat so you can have it. This is the new way to create estimates for your infrastructure. I will tell you that none of these is complete in the sense of if we go back and look at the providers in question, none of them actually has all of their cutting edge services in there at any given time. So for example, where's data transfer covered, right? Just know that pricing is largely a function of you can forecast most of it, but you won't actually know what your actual cost is until you run a proof of concept. So just a word of caution. They try really hard to make it so that you can do some forecasting, but you're probably going to want to add about 20% to any forecast you get off these calculators, because typically they don't take into account everything. Best thing to do, stand up the entire infrastructure, load test it, run it for an hour, extrapolate the costs from there, right? That's the best way to find your costs for cloud. Because remember, the two things are hard, right? Harder in cloud, security and billing, because we just haven't figured out those models yet. Thank you, by the way, for everybody who's taking care of everybody else. I appreciate that in the chat, because I definitely was going to answer the question in question, but it sounds like people are taking care of people, so I love that. Thank you. All right. When it comes to infrastructure as a service, for the most part, the big three providers are the same. They offer pretty much the same features. They all offer virtual machines. They all offer containerization. They all offer some form of serverless. They all have batch processing. They all have some way to elastically scale the virtual machines automatically. I say automatically. It's based off of metrics, right? They all have a partnership with VMware. They all have a partnership with Red Hat, right? I don't think Google has a cloud, like a cluster software, but I'd be surprised if that was actually still true. But for the most part, when it comes to infrastructure as a service, they're all comparable. They're all very competitive with each other. Pricing wise, I would say that Google tends to be the cheapest. Microsoft tends to come into the middle. Amazon tends to come at the top. But here's the cost of that. Amazon tends to be a little bit more reliable by far than Azure, right? Google tends to be second in terms of reliability. So there's these weird things, right? And by the way, performance-wise, like there's a company called CockroachDB. I should find that link actually and post it. CockroachDB does an annual performance test of their database across all three cloud providers. It's an annual report that they run. I think they've run it like 3 years in a row. And they actually show the performance characteristics of the same database with the same data set, with the same testing methodology, with different size of boxes across all three providers. And sometimes they're really comparable, but most of the time Google wins, which is interesting because Google's usually cheaper, right? Google, by the way, does not have nearly the feature set that AWS and Azure has, but it is cheaper, and typically their stuff is more performance. Performant being a very software-y word, right? But typically they're more performant. So, by the way, I checked the cost on this because this is a C5 extra large with 1 terabyte. It's dropped to like, 214 or something like that. So pricing is just slightly off. Don't use this as an absolute rubric, right? But like prices have dropped like maybe a few bucks for each of the providers, right? but that gives you a good idea. Google is usually the best value per dollar. Amazon is typically the most reliable and has the most features. The reason, by the way, I think Azure is a good cloud provider is not because of their cloud. Azure, like Google, really understands the business and development experience. And so Microsoft is trying to make it so that you can actually just deploy your application with a button from a developer's integrated development environment and just push it out. So Microsoft's trying to make it so that your ability to deploy is like really push button and seamless and cheap and like efficient. The only problem is that Microsoft probably needs to work on their security, which if you've looked at the news, you probably know that already. And they need to work on their reliability. They have a bunch of challenges around that. So you've really got to like test all three providers to see who has the features that you need now and the features that you might need in the future to really choose a provider. Just to say this, just to be safe, is that AWS is always a safe bet right now because they have the most features, the most reliability. They will be slightly more expensive by way of comparison, but you're paying for what you get what you pay for, right? You want a secure environment that has a bunch of features, you're gonna have to pay a little bit more, right? You want an environment that sometimes shows up with some reliability issues, then pay for Azure, right? And if you want something that has the least amount of features but the best bang for the buck, then that's going to be Google, right? Google has the least amount of features compared to the other two providers. Google would kill me if they heard me say that. So that's IaaS. So that's infrastructure as a service. Here we were talking about platform as a service, right? Platform as a service basically says like, and this is mainly like data store applications are probably the number one. Notice that they're all comparable. Amazon's RDS service actually has MS SQL, Oracle, MySQL, and Postgres inside of it. So a lot of what this stuff is listed over here, right? Notice this says SQL Server, MySQL, and Postgres for the Google Cloud. They're all super comparable, right? It's funny they list SimpleDB. SimpleDB, by the way, is no longer a product on Amazon. That was one of their first offerings. So if strike that, if you go look for SimpleDB, you're not going to find it. By the way, all of these providers have far more database services than are listed here. So, like to give you an example, this is AWS. I know it's a pie chart. I'm going to make it larger. There's all of AWS's database services that are officially marked as database services. There's about 4 others, by the way, that are in other categories that are actually not here. So RDS, DynamoDB, Elasticache, right? So all the providers are like this, just so you're aware. All the providers have more services even than are listed here. But these are platform as a service. They're all very comparable. Some of them are very specialized, but again, they all share pretty much the same capabilities. I mentioned before, by the way, that if you're also looking for other platforms that the cloud providers don't provide, I'm going to pick on AWS again because I have this as an option. Oh, you know what? Let's actually go here. They have a marketplace that allows you to actually see like other solutions from other like places. So like, for example, let me choose EC2 because that'll make things, I think, a little bit easier. If we go into EC2, this is the virtual machine service, right? And we come up here and we say, you know what I really want to do is I actually want to launch an instance. So I go to launch an instance, right? And I'm actually looking for something from the marketplace because what I really want is I want TIBCO. Guess what? There's TIBCO. This is not a service that AWS offers. This is the marketplace. So vendors have come into AWS's, Azure, and Google's marketplace and said, we want to make our software available to people on the cloud. You don't offer this as a service. Can I just put my software into your ecosystem and people can come and buy it and use it, right? I think I was joking earlier about Checkpoint, right? This is the bring your own license version. This is where the license is included in the purchase, right? You were looking for something else like, I wonder if NetApp is here. I don't know if it, oh yeah, there's ONTAP, right? For AWS, there it is with high availability. You can find pretty much any vendor you're looking for, right? Out here, any major vendor. So they all have a marketplace that allows you to hook into third-party software. So it's not just about infrastructure as a service, platform as a service. You can buy other platforms from other vendors inside the ecosystem of these cloud providers. Now, the last layer is SaaS, right? By the way, they all have SaaS. Matter of fact, this is something that I think Google is actually exceptionally good at. But Lambda and Functions, Azure Functions and AWS Lambda, are also great comparable serverless. You just give them code, by the way, and if you want to run 1 billion instances of that code, they'll do all the scaling and the operating system management and all that for you. You won't even see any of that. You just say, look, I want you to run these functions with like 1 gig of memory and 2 processors, and just go to town. And so however many times this function is invoked is how many times it will run, right? And so if you want to run, hundreds of thousands of these within the course of a day, you don't have to manage the operating systems. You don't have to scale it. You don't have to touch it. You just put the code in and say, go, and it will run as many times as it's invoked. Now, there are limitations, by the way. It's not like someone could like spin up 1 billion of these without you having to go in and say, hey, by the way, allow 1 billion of these to run as your cap. But out of the gate, I think you get like 1,000 concurrent executions at any given time. It's all you have to do is go in there and just turn the dial if you're willing to get to a higher number, right? One thing that's probably worth mentioning is that because virtual machines, containers, and serverless are the 3 ways in which we can host applications, containers and container orchestrators are rampant on both systems. That Kubernetes thing that I was talking about earlier, the container orchestrator that everyone's trying to get mastery of so they can run multi-cloud in an interesting way, they all have an elastic Kubernetes service, right? You've got AKS, EKS, and GKE for each of the 3 cloud providers. Those are the Kubernetes engines that these services provide. You could actually create a deployment file for a container and run that deployment file out of the box with no modifications on practically each of these providers with no issue. It does depend on the container, but for the most part, that's true, right? So just note that they are all competing in every space. Machine learning, they're competitive. Containers, they're competitive, right? IoT, they're competitive, right? Security functions features, they're competitive. So they have, for example, all have object storage. They all have archival storage. They all have file storage. They all have a content delivery network. Now, I'm not going to run through each of these in detail because I'm not necessarily want you to, you're going to memorize them, right? We're not playing bingo, although I wish we were. We'd probably learn a lot if we played bingo, actually. Thought for next time. We'll play bingo and I'll put it like $100 Amazon gift card for like the winner, right? 50 for the second, do something like that. That sounds like a good idea. So there's different services in here, but they cover the basics that you already know. You already know what file storage is. You know why? Because you've mounted drive letters on your Windows operating system. You already know what archival storage is because you've got files that you want to store away for a while because you never know, like you got to keep it for 7 years for the IRS or something like that. You've already got compliance and archival storage. You know what object storage is because at least your developers, right, have probably decided that they're going to store a bunch of small objects through APIs, almost like how we used to use FTP and SCP and all that. But they're going to put this out somewhere and they need to store a bunch of files out somewhere that they can actually use and get access to. But there's a bunch of services out there. And let's go back to the Azure window for a second. Azure, AWS. We're at the AWS window, not the Azure window. Ignoring this whole thing on the right-hand side, look at all these services. I'm just scrolling down. These are just the AWS services. Do we really need to know all these services? No. So going to AWS or any of the cloud providers, by the way, to look at services is like going to the grocery store hungry. Do you know what happens when you go to the grocery store hungry? I'm like a vegan, basically, who occasionally eats meat, but I end up with like Cheese Whiz and like Slim Jims inside my basket when I'm hungry. I'm like, I don't even eat that stuff. It's not even food, right? Although they are tasty. That's what happens if you go to these cloud providers and you're like, I wonder what they have out there. That's a bad idea, right? You will get overwhelmed with the sheer number. They have a quantum computing service. There's a quantum computing service out here, right? Called Bracket. I don't even know where they stuck that thing. There's a VR service, by the way. Here's a satellite service. Yes, I'm on AWS. Here's the quantum service, by the way, called Bracket. Here's Sumerian, which is the augmented reality, virtual reality service. Here's managed blockchain. If you want to make your own altcoin, right? If you're following the whole rage with Bitcoin and Ethereum right now. Here's a robotics maker. My point to all of this is that you're gonna look for the services that you need. Do you need a data warehouse service? Great. Come out here and type in data warehouse. Oh, look at that. Data warehouse is ready to go. And you're going to get all the things related to data warehousing, right? Are you looking for Oracle? Guess what? Got a managed database service. Are you looking for, I wonder if Neo4j shows up actually. I wonder if that shows up. That would be awesome if it does. Oh, it doesn't. Graph. Like you're looking for GraphQL or you're looking for IoT. Oh, IoT is another good one, right? You're looking for IoT. Here's all the IoT services. My point being is that you're not going to come out here and scan through all this per se, right? You're gonna find the service that you need. And go ahead and assume, by the way, that all three providers have a service, because for the most part, they stay competitive with each other, and most of them do. The only one who doesn't typically have that service, as you've probably already noticed, is Google. Google doesn't necessarily they like to compete in very specialized areas. They don't want to compete on everything, which is actually probably smart of them. Right, here's some IoT services. Oh, look at those big data analytics services. That's a lot, right? A lot of services, because insights and analytics, data is more valuable than oil now, right? AI and machine learning, tons of services here. SageMaker, Alexa skills. By the way, there's even more now in this space. There's probably double the services. I've got OCR services that will recognize images and extract text. I've got services that will act as chat bots so that you can actually have a bot talk to your people before your help desk people take it. There are so many services out here now. I've got things that will do natural linguistics translation. I've got things that will do speech recognition, all kinds of stuff. And then we've got our security services like authentication and access management, including, by the way, most of them have Active Directory emulators of some type for Microsoft services. There's literally double the security services now across all the providers. If you're looking for something to do like threat assessment, you can get that. You're looking for something to scan all of your data in S3 to make sure it doesn't have any social security numbers or credit cards, and it uses machine learning to do it, there's a service for that. You're looking for something that's going to act as a layer 7 firewall for all your stuff, we've got that. You want advanced distributed denial of service protection, we've got that. Like, there's like, oh, it's ridiculous. At last count, there was like 187 macro services, of which there were 6,000 microservices inside AWS alone. So just know the security services and tons of stuff out there. Quantum services, VR services, blockchain services, ledger databases, all kinds of stuff. Now, I've now told you basically the main takeaway from that is like, well, there's a lot of services and they've got services for a bunch of big sections. So I need to be very focused about what I'm looking for when I go look at these providers to evaluate them, right? I did mention at the beginning, by the way, that your data is actually stored in a particular place. It's not just the amorphous cloud, right? It's not like there's a huge data center floating up in space, right? That has that would be cool, by the way. I wish they did that. By the way, Microsoft did actually have data centers underwater off one of the coasts for a while. They had an underwater container that they sunk for cooling purposes, and they actually had that like taking like data for a minute. It wasn't publicly available. It was a nice little experiment. But your data is sitting somewhere. As I mentioned before, every single provider has these regions or sometimes they're called availability zones. And the availability zones are usually subdivisions of a region. So if a region is Virginia, they'll have anywhere from 3 to 6 availability zones that will make up that region. If there's a region in Boston, it'll have availability zones around that region. Now, you don't know where they're located. You just know they're near Boston. And most of them, by the way, don't meet like DR requirements. So you're gonna need to go to 2 regions if you want to get DR in most cases. It just depends on the provider. They'll tell you, right? You're looking for a 25-kilometer distance separation. They'll tell you whether or not their data centers are actually 25 kilometers apart and can meet DR requirements. You need 100 kilometers. I don't think a single one provides like 100 kilometers, but you know, I could be wrong about that. So here you can see the different geographies. Let's pick one, right? Let's look at Azure's global infrastructure. That's a pretty good spread, isn't it? By the way, they all tend to chase each other. See how there's a bunch of data centers down here in Sydney, and there's one in South Africa, and there's one in Brazil. Stay with me for a second. If I switch to AWS's global infrastructure, let's look at South America. Guess what? They've got some, hold on. Whoa, they're not giving me the right map. Hold on. Here we go. Better map. Look at this. Brazil, South Africa. Hey, look, Sydney. So they tend to chase each other. They tend to chase each other about where their locations are. The locations are remarkably similar. They tend to congregate around the same areas. What areas are those? Where are the most people living? Right? Where are the most people living? And Google's no different, just in case you missed that. If I choose Google, Google doesn't necessarily have a pretty map, but they'll tell you like Oregon, Los Angeles, Salt Lake City, Las Vegas, Iowa, etc. Sao Paulo, which is Brazil. They've got something in Canada, right? Europe's the same way, right? Asia Pacific's same way. So they don't have anything in Africa yet, but they will, because they do. They just chase each other. So know that wherever your users are located, you can actually get your services, your virtual machines, your containers, your serverless closer to those users just by picking a region that's close to the users in question. Here's a word of caution. Regions vary by cost. Sometimes this cost can be significant. Let me just pick on somebody. I'm gonna stick with AWS. California, by the way, is 10 to 30% more expensive than any other region in North America. Tokyo is 10 to 30% more expensive than any other region in this area. So unless you have a stringent need, make sure that you're checking your data and legal compliances. Make sure you're checking for proximity to the user base that you're going to be serving, and make sure you check the costs, right? Because some of these regions, by the way, for the most part, they're all the same price. Every once in a while, you'll run into like a land, power, cooling tax, where the cost for the same service is 10 to 30% higher, right? So just pay attention. If you need to go global, by the way, think of using a content delivery network instead of actually trying to co-locate services globally. A content delivery network in a lot of cases will actually provide you with the speed you're looking for. But just something to keep in mind. Like I used to work with a company, and the data science team was in California, and I looked them in the eye in California and said, do not start up anything in the California region. Go to Oregon. That cost them a millisecond or two, right? What did they do? They started up a bunch of stuff in California, and our bill went up by 30%, right? And it was like, right? Don't do that. There was no need, by the way. 2 milliseconds. They weren't working on anything that required those latency sensitive. So just pay attention, because you need to consider your legal compliances, proximity to your users, and your costs, because there can be variability on all 3 providers for costs. Okay. Okay. So what do we do? Well, we went through and talked about the sheer vast number of services. We talked about how AWS tends to have a little bit more of priciness, but they've got the best reliability and the most features, right? Per service. Azure kind of falls in the middle around features. They tend to chase Amazon really strongly. Their reliability, not that great. I know this is a subjective statement, but you'll hear that echoed by many, many different people, right? Engineers who are like, why is Azure down again? And it's not down for everybody. It's just slow or having some kind of reliability issue. Google tends to be the most specialized. They are also the most valuable for the like bang for your buck in terms of like what you actually get, you know, for the dollar that you spend. They also don't tend to chase the others around feature sets, but they tend to be really good at what they do. And Azure is the best at the developer experience, probably falls most closely by Google. Amazon would hate me saying that, but they just don't. They're a bunch of engineers. They're barely business people, right? They're a bunch of engineers who make a really good engineering product, but they really haven't found out how to woo developers, which you could argue Microsoft's been doing for 20 or 30 years now. Microsoft's really good at wooing developers. So is Google to a certain degree. Amazon's trying to get there, recognizing that that's a problem, but Azure's, Microsoft is probably the best at it right now. So easily. Okay. Questions, comments, soliloquies, interpretive I stances of your career? I'm open to all of it. We are recording, so I'd love to see that. No? Okay. So here's what I'm gonna do. It's 2:12 now. Let's take a 10-minute break. I'm actually gonna put a timer up on the screen. I'm gonna stop recording. You're gonna see it count down from 10 minutes down. When that timer approaches 0, let's get back online and let's finish the rest of this and go through the other things around security and billing related to cloud. Okay, see you in a bit. Let me resume recording. One, I have shared the student ebook from the courseware in the chat. I have also, you should have gotten an email or even a link to this as well. The Kindle ebook, the Enterprise Cloud Best Practices for Transforming Legacy IT. The framework for this particular 3-hour was structured off of that. The book was published in 2015 by a veteran of cloud at the time. Still applicable even today, at least from a broad strokes concept. So please feel free. Make sure that you've gotten it. Please feel free to email us if you don't. Probably the best way to reach us is at support@web8solutions.com. If you find that you didn't get the book for some reason, but it should be in your junk folder. It was probably, by the way, sent to the email address you registered. That might not actually be your Amazon email address. I will tell you that I got a copy of the book as well sent to my email address, and I just opened it up underneath my Amazon address and it worked fine. So it's not like you need to associate it with the address in question. You can just log in with your Amazon account, click on the link, and it will open the book in that other account, not the one that you got emailed to. All right. So we're going to talk about application migration, security, and some billing considerations. And that's it. It's 2:15 now. That'll be our last hour and 15 minutes together, is to talk in general in some broad strokes about some ways to think about how to approach these problems from a cloud perspective. First thing, application transformation. So I mentioned this before, is that infrastructure as a service, like using virtual machines to go to virtual machines in the cloud, is considered to be one of the most like simplistic and probably honestly not preferred ways to get in the cloud. If you need to lift and shift over to virtual machines, do that. You know, don't let anything I say shift that. You know the needs of your business, but it's not necessarily the most efficient way to get in the cloud, mainly also because any of your bad habits around virtual machines, and we all know we're on to our stuff, right? We know where we're challenged when it comes to provisioning virtual machines, where that might be. You're going to take those habits with you. So you can think about, and it's easier to do so when you go from the same technology in your private data center to the same technology in your new data center or public cloud provider. If you switch from an older technology like virtual machines to containers, you have to reevaluate your processes, and that usually initiates transformation. But of course, it's also more disruptive as a result. Ultimately, refactoring, rescoping, re-architecting your application is probably the longest term goal, like the longer term goal, to maximize your usage of AWS. And there's a lot of planning involved in that. So since all of this is now software defined networking, right? you still need to think about and plan for and consider not only your current challenges that you're running with your application, right? Both from an infrastructure perspective and the application itself, but how to evolve that in the cloud. You need to, and by the way, that's just the technology perspective. What about the people and the process perspective? What groups are supporting these technologies? What skills do they have? What's their mindset? You know, just to say this, and this has nothing to do with age, by the way. If you're dealing with people who have a very fixed and rigid mindset, then the fluidity of cloud or the fluidity of a new technology, there might be some resistance there. And so even if they say yes, they're going to act no, because they actually don't want to do the thing that you're asking them to do, which is the hardest thing, which is to change. When we do these digital transformations and the application modernization, application migrations, we're asking people to change either how they see the world, how they manage the world, how they interact with the world, how they think about the world. And that's tough for us, right? So it's more than just technology. It's also the people, and it's also the processes that bring these two together. So we also have to consider things like, what's the value? That should be the first question. What's the value? If I spend $100,000, what value did I get out of it? Did I get $1 million of value? Awesome. What's the value of me going from my private data center to cloud? What do I gain? It's not just operational offloading. What is the value of that, right? Do I get more agility? Do I get more automation? Do I get utility computing? You should. If you're not, it may not be worth it. There might actually even be a place where staying in your private data center is more valuable than going into a new platform. I will tell you, in general, in the industry, that's not true. Almost invariably, Amazon is typically running data centers more efficiently, right? Because they're focused on one purpose and one purpose only, running infrastructure services for consumption. Most of us are not in the business of running infrastructure services and consumption. We're in the business of doing consulting or offering, email services or data transformation services or advertising platforms. We run infrastructure because we have to do that thing. But Amazon's sole focus, or Azure's sole focus, and Google's sole focus is to provide infrastructure as a service. So they're typically better at it. Now, applications can typically be categorized, I would say, honestly, into two buckets. One is you bought it from somebody else, and the second bucket is that you wrote it, right? Probably there's a third category in which you actually got it open source, so you actually just took it from somebody else because their licensing allows you to do so. So you either got it from a vendor that you paid for it, you either took it open source from somebody who wrote it for you, or a group of people who wrote it for that purpose, and then you either wrote it yourself, right? So you wrote a custom application. Now, these applications could actually all be cloud native, and that they're actually purpose built to run on cloud. But usually that's very intentional, like people know, right? For example, Jenkins, which is a very popular CI/CD tool, has actually two major versions. There's just regular Jenkins, and there's Jenkins X. Now, these two sets of services don't have feature parity, but Jenkins X was built as a cloud native application. Older Jenkins written in Java was not. So you got to know the pros and cons of that. But typically a cloud native application, regardless of whether you paid somebody else for it, you got it open source, or you wrote it yourself, they follow certain characteristics that make them optimal for running in a cloud environment versus a traditional private data center. Now, when you run these applications, right, how does the application scale? Does it maintain strong session state within the application, and therefore elasticity has to take in state changes, right, within the application? How resilient is the application if it loses one of its members, right? Is that going to cause a problem? That's a resiliency, by the way. How does this thing authenticate? Is it federate through Active Directory? Does it use LDAP? Does it use its own unique data store? And then if we do run an application, do I need one per customer? Or can I actually run multiple customers on the same application, right? So there's some characteristics to the applications that you put up there that you need to consider, particularly during migration, that could make them, in a sense, more cloud native. Other characteristics are, is this going to be accessible privately, or is this going to be accessible across the entire internet? Meaning I'm only going to allow certain people to get access to it. And then, are there multiple tiers of service? For example, is there a web server with a middle tier application and then a backend database? Or is it like 7 tiers and it's got like 5 presentation layers, 7 application services, and each of those application services has a database on the back end, right? Like a microservices architecture. So the other thing around applications is, some of them, by the way, now are focused on mobility, not just web, like a mobile web interface, but also a web app. And so those applications also must be considered. You've got to think about the entire characteristics and dynamics of your application characteristics and ecosystem. Hold on just one second. All right. So because of these characteristics, modern application development is focused heavily, not just on the characteristics of the app itself, but because we're continually adding features to try and create a frictionless experience for our users. We're trying to add features that make it so that our users will pay us to use the application in question, right? By the way, sometimes the application or the service that we're offering application hosting. We're working for the DoD and we're saying, look, we'll help you figure out how to host your apps, but we're not actually writing the apps. Even that, by the way, has features to it. What if they come back and say, look, I want to do this now on AWS, I want to do it on Azure, I want to do it on Google, I want to switch out from Linux and I want to use Windows? Those are feature requests. Are you doing that in a way that allows it to be a continuous integration and continuous delivery model, which means you're automatically pushing features out, testing them, and then pushing them into production if you're doing continuous deployment, right? And you need to be able to release features to test them, continuously and quickly. Developer writes something, push it out. Someone else writes something, push it out. How do you push it out in a compliant way that doesn't break the system? What if someone makes a mistake and pushes out code that actually causes either a security hole or actually just causes the whole thing to fail? You need a CI/CD system, which is what continuous integration and continuous delivery is, in order to be able to not only deliver the application itself, but you need a CI/CD system for your infrastructure. That automation and testability that we're talking about is why cloud made DevOps real. It's because now, if all of your infrastructure is a software object, guess what that means? You can test it. Did you just create a network as a software object? Great. Does it have the right IP addresses associated with it? Did you just create a storage object, a virtual hard drive that you're going to attach to your virtual machines? Great. What size is it? You asked for 8. Did you get 8 gigabytes? You asked for a virtual machine that has 2 processors and 8 gigs of RAM. Did it make a virtual machine with 2 processors and 8 gigs of RAM? So don't think that testing is now just limited to software. With the advent of software-defined infrastructure, you now actually can test all of your infrastructure creation. So running CI/CD, continuous integration, continuous development, is essential nowadays to be able to deliver automated software delivery and automated infrastructure delivery frequently, multiple times per day, in order to meet your customer needs. This is the difference, by the way, as you see in this little rubric at the bottom, between 4 releases a year, 12 releases a year, and 100 releases per year per app, right? Amazon, if I remember correctly, is doing 6,000 deploys a day. Now, is that all to the same service? No, no, it's not. It's not all the same service, right? But they're doing like something like 6 to 8,000 something deploys a day. It's ridiculous, right? That many deploys a day in production, not in their testing environments, in production. We don't need 6,000 deploys a day. You need the number of deploys that you need to be able to create business agility. Because remember, every deploy, if it has features in it, is more potential dollars for your app to draw in from customers because you are solving customer problems in a frictionless way. More releases means more ability to experiment. Experimentation is king. That's innovation. So the cloud provides this software-defined infrastructure so that you can test all this and make it happen. right? You can recreate development environments, you can recreate testing environments, you can recreate production environments like that, right? Spin them up as you need them, destroy them when you don't. So part of the application transformation methodology is not only just to understand the characteristics of your app and whether there's value in you lifting and shifting or re-architecting it, but you also want to consider what things do you need to change about your app? We talked about resiliency and elasticity and multi-tenancy and all that before, but you might need to re-architect to achieve those. So the transformation methodology that we think about is that how can we avail ourselves of the unique pieces that cloud can offer us, right? Going straight for infrastructure as service just because it's familiar is probably a comfortable thing, but will not allow you to achieve the disruption you need to be relevant in your industry. So you have to assess each application to see what kind of porting, whether it's a rehosting, a replatforming, a re-architecting, a refactoring, or even just a retention, what that looks like. So there's a couple of different modernization strategies to think about. First is, it might not be cost effective to take your application and push it to the cloud. You might just think to yourself, you know what, let's just replace this whole thing. Not, let's just buy something else. Let's just write something else. Let's just replace it. We're not going to shift it. We're not going to migrate it. We're just going to, just done. Retire this one, put another one up, right? You might actually then think about rehosting an application, which means that you're just going to take it, lift it up, and install it into a cloud environment, test the infrastructure, make sure everything's cool, but provide a similar environment. You've now rehosted it from the host that it was on to a host in the cloud. You've probably not gained a whole lot of efficiencies, maybe some operational efficiencies, and that's it, right? Then you might need to refactor the application, which means that you're like, we're going to mess with the code a little bit, right? We might like horizontally spread it so that we get more resiliency, but you're not necessarily changing deep the entire functioning of the application. You're just changing some of the code and maybe it's in a relationship with each other. So you're doing some mid-level changes. And then there's redesign, right? Also known as re-architecting, where you're basically like, look, we're going to rethink this thing from the ground up. We're going to take our code and just restructure it, re-architect the whole thing, and figure out exactly what is the optimal way to leverage cloud to get this to happen. AWS in particular posted a blog on these kinds of migration strategies. I want to say this came out like a while ago, actually. Pop this out here. And this one, by the way, talks about the different phases of a cloud migration strategy, but it talks about like repurchasing, rehosting, right? Replatforming, refactoring and re-architecting, and then of course, retiring and retaining. So I just posted that link just in case you want to read it yourself. I think NetApp actually like made some reference to it. So I just pulled like the most recent one. But this is a good way to dive deeper into consistent strategies that you could use for application modernization. Remember, the options here are you just lift it, you leave it, you lift it and put it in the cloud as is. You completely replace it, which is the whole other end of the spectrum. You're just like, I'm just going to replace this with a whole other thing. And then there's steps in between where you either refactor it or re-architect it, but you're still using the same basic app just to make it palatable to the cloud and optimize your cloud usage. Now, just to say this, you have to be considerate of all of the things that you figured out in your private data center, you're going to need to figure out in the cloud. For example, if you had monitoring for your VMware stack, your virtual machines, you had monitoring for your runtimes and your application, how are you going to get monitoring and logging for that on the cloud? Most of the time, it's the same. Just to say this, it's the same. You use the same tools, it's usually totally fine. Sometimes it's different, right? But all of the information that you were getting before, all the processes that you had before around your private data center, when you go to cloud from an operational security perspective, you're going to have to relook at those because you might use the same processes, you even might use the same tools and technology, but you might need new ones because it is the cloud. Things are different. Everything's software defined. If you just think that you're going to take the old way of doing things and put it on the new way of cloud, could do that, but it probably won't get you the efficiencies that you're looking for. You also need to look at service levels. Your data center might have like 6 nines of uptime, right? Amazon, by the way, typically offers like 4 nines for certain services. But if you get 2 or more services, which they recommend in parallel, then you've got a lot more high availability and resiliency, right? So again, you need to look at SLAs when you consider like an application migration about the services that you're going from and the services you're going to. And then of course, federated authentication is not necessarily a problem nowadays. If you're running Active Directory in your data center, you can just hook that up to AWS or to Azure or to Google. There's no issue with that. But you do have to make that extension and transformation, because otherwise, how are you going to control who gets access to what on the cloud provider, right? So you do need to think about that, how you control access. What's your strategy for making cloud services available to your operators internally, right? Don't do what I talked about at the beginning, where it's like, hey, guess what? Free for all. Everybody now gets access to, Azure. That's like, no. Don't do that. You can't give everybody unfettered access to a utility service. It's going to get expensive, right? Other considerations is like, how is the app going to scale? How are you going to scale up or out? How are you going to scale down and in? How are you going to performance benchmark your application? But and the other thing to think about is that most network providers are not going to charge you for putting data into their platform. They're going to charge you for pulling data out, right? So if you're pulling out 4 terabytes of data from the data center every day, that might start to add up. You might need to change the way your application does that. Maybe you're pulling it out because you want to run reports. And maybe now what you need to do is run your reports in the cloud, so you're not pulling out 4 terabytes of data a day from the cloud. So all of these dependent applications like that are associated with your app, you also must consider what they're doing as well. You have to take your entire ecosystem and think about what it would look like in cloud and figure out what makes sense to be in cloud and what doesn't. And then, not every application has to go. If you've got a 10-year-old application that's at the end of its life cycle, just retain it and then retire it when it's ready to be replaced. You also need to consider, by the way, any legal compliances, any costing compliances, right? You have to do a full analysis to really know whether or not application is a good fit for what you're trying to accomplish in cloud. Remember that any opportunity for migration is an opportunity for transformation. Transformation is extremely uncomfortable and disruptive. So you got to look at the skills you have, what the business goals are, what are your time frames, because we're always surrounded by deadlines and constraints. How much money do you have to do a transformation? You might not have much. So then you're probably just going to do a lift and shift at that point in time. You're not going to actually do any transformation and then get into a platform. So consider, though, new architectures. If you are able to do transformation, there are new cloud patterns that you want to look at if you actually want to migrate your app in. Talk with an experienced cloud architect, or just talk to your rep. All of these companies, whether it's Google, Azure, or AWS, want to partner with you to not just increase your cloud. It's not like they're just looking for money. Don't get me wrong, they're running a business. They do want you to use their service. I can't tell you how many times Microsoft came back to me and said, hey, by the way, I noticed you got a bunch of systems running and I need you to shut them down because you're not doing anything with them and they're not doing anything on them. Like, do you need them? I was like, no, thanks for telling me. Shut them down, $10,000 a month, gone, right? Or how many times AWS came back to me and said, hey, how can we help you get more efficient and lean with your AWS spend? They weren't like, hey, we want you to spend more money. They were like, how do we teach you to be better with AWS? Questions that get asked all the time. Remember also, I ran into this recently actually with SAP licensing, right? Is that some of these licenses, by the way, don't support the cloud model. They just don't. They don't support elasticity or whatnot. Please make sure you do a licensing assessment for your application before you migrate to cloud. You might find, especially with some of the larger enterprise apps, that you've got some kind of licensing thing in there that will not allow you to run cloud efficiently, right? Or you need to like be aware of the limitations, right? Or for example, like they might require you to run on dedicated hardware. Things to just be aware of. So Cloud-enabled applications or cloud-native applications are designed to take advantage of the infrastructure. You've got a couple of different things to think about with these applications that are relevant to determining whether or not you're going to basically repurchase, right? Like drop something and replace it with another service. Let me blow this up actually so you can see it better. Or whether you're going to rehost, which is also known as lift and shift, right? Whether you're just going to take an application, lift it up and push it over, right, to the cloud. Whether you're going to lift, tinker, and shift, which is replatform, which is where you're going to lift it up, make some changes to it, refactor it to a certain degree, and then push it out, right? Refactor and or re-architect, where you're going to deeply change it. You're going to really refactor and change it, change the design, change the fundamentals, same code base, but a lot of changes in shift, and you're going to push that on the cloud, and that's going to maximize your cloud efficiency. And then lastly, is whether you just retire it or just keep it as is, right? I had one company, by the way, that couldn't move to cloud because they loved CapEx. Their whole financial books model was on capital expenditure, depreciation, this whole 9 yards. They loved buying hardware and deprecating it over time. They had hardware that was, by the way, they bought that was like 7 years old, 4 years past its end of life cycle, and that was their core infrastructure model. So in that case, they retained that app. They didn't actually migrate it over to cloud after we did our analysis. So just things to think about. Okay. If you can, by the way, get out of the business of doing things that are not core to your business. If running infrastructure is not core to your business, then get out of the business of running infrastructure, right? That's what the cloud providers provide, by the way. Focus on the things that are core differentiators for your particular business or your customer's business if you're supporting them in doing that. And just bottom line, assessment is essential. Assessing licensing, how it's structured, your people, your processes, your technology, essential for application migration and modernization. Cool. Questions? Comments? If you've got sock puppets, I'll take those too. In a little plate now. Okay. Yeah. So let's talk about the two harder things inside cloud. So in Kubernetes, by the way, which is that container orchestration layer, networking and security are the two hard things. Oddly enough, in cloud, the harder things are security and billing, right? So let's talk about the first of those, security. One, that shouldn't just say cloud security isn't a one-size-fits-all solution. It should say nothing is really a one-size-fits-all solution, right? There is no one like general checklist for security that you can follow that will apply to your situation, right? And that's because, right, attacks and therefore remediations come in a variety of different forms in different places, right? So each of the cloud providers have very similar ways of managing security, like from a customer perspective, not from the provider's perspective. But you need to have a security plan, and you need to basically apply the methodologies you're using now and update them for cloud providers. But here's the difference. All the providers, for the most part, use a shared security model, which means the higher you are up the stack from infrastructure as a service to platform as a service to security as a service, the more the vendor does security for you. The more the AWSs and the Azure, Microsofts and the Googles do the security for you. The lower you are down the stack towards infrastructure as a service with virtual machines and basic networking and storage, that's on you to secure that. So if you can, try to lean more towards the platform and security as a service, because you're not actually in the business of security, although it could be argued that we actually are all in the business of security, but you'd like to reduce that footprint as much as possible, because what you're really in the business of is providing value to your customers. If security is part of that, awesome. If it's not, then you might want to think about offloading that to somebody else. Here, by the way, notice that in red, that's the cloud provider's responsibility, and the gray is the, the blue is the customer's responsibility, the gray is the cloud provider's responsibility. Notice that if you're on premise, it's all you. You're responsible. We are the ones who have to secure everything. And again, that reduces as you get to software as a service. Notice that physical security disappears almost immediately the minute you get a virtual machine. Then host infrastructure starts to diminish. Then network controls start to diminish. Then app, identity, client, and endpoint protection, all that starts to diminish. But notice that your data classification and accountability never goes away. If you put data in these providers, it's your responsibility to classify it and mark it and defend it appropriately. Some security features, by the way, by default in these providers, everything is locked down. Meaning you cannot just accidentally spin up a virtual machine and whoops, it's on the internet and now everybody can see it. That's not how this works. By default, every service is locked down from the internet. You have to go in and punch holes and click buttons and check boxes to get the firewalls around these things opened up. So when you see in the news, another AWS customer today accidentally used S3 to share, they did that to themselves. AWS goes to great lengths as an example, so does Azure, so does Google, to make sure that you know that when you say yes to these things, you are opening her up to a lot of intense scrutiny from the internet. In case you haven't figured this out, it's 2021, the internet is not a safe place. I'm not saying that web pages and stuff are not safe, but like exposing yourself to the internet is going to expose you to a lot of unwanted attention, right? And so when you run these infrastructure services, you just have to be mindful about what you're posting or sharing across the internet. For PaaS, which is also true, by the way, for infrastructure as code, also true for SaaS, is that you need to think about logging, any IP restrictions, any layer 7 attacks, which is true for all of the particular layers, right? And just make sure that you've got authentication and encryption, both for data at rest and data in transit, necessary. But you also need auditing capabilities. So this is where logging and auditing and tracking actually come in really handy, because you actually have to have them. The other piece of this is that in order for security to really function properly, you need a governance and compliance strategy. How are you going to govern the availability and the consumption of these resources internally to the rest of your people? You've got to think about this. So you need to have a plan in place. You need to have a strategy that follows some principles that's been socialized with all your people about how to make these offerings out to your internal customers as well as your public customers. The great thing about Booz Allen Hamilton, by the way, or Booz Allen, is that you know, like for you guys to get access, again, to pick on AWS, you have an internal portal that you go to where your operations and security teams have basically controlled access to AWS GovCloud, which is a particular flavor of AWS, in a very controlled manner, right? That's great, actually. That's a strategy. That's a governance strategy. That is governing the cloud by saying, look, we're not giving you unfettered access. We're giving you controlled and approved access to AWS, right? And that includes things like auditing, compliance assessments, doing vulnerability assessments, cost management, right? You ever, if you feel like you want to talk to the security team at Booz Allen, just go out there and start an AWS account on the public site using your Booz Allen Hamilton address. Don't do that, by the way. This is a joke. Don't do that. You'll get an email. Your manager will get an email, and the security team will probably email you and say, "Hey, did you mean to start an account? And by the way, what project ID does this belong to?" Right? So if you want to start your own personal account, use your personal email address. But if you try to create a public account with your bah.com email address, you will get some attention from the security team who will be like, "Hey, what project does this belong to?" Right? Why aren't you going through the portal? That's governance, by the way. That is a way of monitoring, controlling, and assessing access to these cloud services. So by the way, what Booz Allen does for you all in terms of scoping that out, you in turn will end up doing that for your customers. You'll obviously be adhering to their platforms because they have their own structures for governance and compliance, but you might also be partnering with them to help craft governance and compliance amendments, right? There are adoption frameworks, which, by the way, there's some great enterprise adoption frameworks out there, right? So it's not just these docs, right, which talk about the cloud adoption framework for Azure, right? There's a whole bunch of stuff here, including things about how to migrate, business commitments, how to align and organize and align around the responsibilities, cloud adoption plans for DevOps. There's really great resources out there. Almost all three of the providers try to provide some information about how to approach these perspectives. And all three of them have published white papers about architectural frameworks, governance and compliance in the cloud, and what's the other thing? Oh, enterprise cloud management. Microsoft's in particular is fun. So they all have help for how to adopt it. Now, we've already talked about multi-tenancy to a large degree, right? We've talked about how all of these are multi-tenant shared services, right? But when you're thinking about security, obviously, you've got to remember you're in an environment where there could be other customers. Now, just to say this, Microsoft, Amazon, and Google, their job is to make sure that no customer can see another customer's data. And I don't know that I've seen I can't remember any violations of that actually. Like even if you sniff the wire, like if you're like looking at packets across the network, you can't see other people's packets, right? It's dedicated to you. All of them, by the way, have single tenant options, both in the public data center and in your data center. So if like I mentioned this before with Azure Stack, with Outpost and Anthos, you can pull their hardware, virtual or physical, into your data center and you can control it. It looks like it's an extension of theirs, but you can run all of your tools against that hardware in your data center if you want to. So you can pull it down. And by the way, most of them operate disconnected from the actual public cloud provider. They do need to check in on occasion to get patches and new features, right? Because it's a vendor's piece of software, right? But for the most part, they can operate independently and separately from the public cloud provider's platform. So you are responsible, of course, on-premise for security end-to-end, but in the cloud, you have a shared responsibility model. How do you reconcile those two, right? Well, you don't. You operate them completely differently. One you have full control over, one you have partial control over. You only need to be responsible for the things that you're responsible for in the cloud provider piece. On the data center piece, that's all you, right? So just make sure interconnectivity between them is secure, but you need two different models to govern that. Security in your on-premise data center is 100% you. And again, in cloud, it's just partial. So you need two different models, or at least fractions of a singular model, to manage a hybrid infrastructure. So best practices here is that centralized identity management. Don't use two identity management systems, one for cloud and one for on-premise. Just use one. You might get to give different sets of permissions for one versus the other, right? Make sure that when you decide to eat a cloud provider of any type, no matter who it is, that you have a unique security plan, a unique security strategy for that provider. They're different. Microsoft, Amazon, and Google operate all slightly differently. So you can use the same general plan, but you're going to have to customize it for the provider in question. What are you going to do when there's an incident? How are you going to audit and detect, right? How are you going to remediate when there is an incident, right? What are you going to do forensically, right? There's this whole vector of like how you're going to do assessment, prevention, detection, remediation, response. There's this whole slew of things around your security plan that need to be considered when you approach cloud security. Here's some specific things, by the way. Single sign-on, which we just talked about. Making sure you're using multi-factor, two-factor authentication. Making sure you're going for least privilege for roles inside, and only expose the services that you want your customers to use. If you don't want people accessing the satellite service or making their own Bitcoin service, then don't give them access to it. Like, I know that makes like common sense, but just a reminder, if you give them unfettered access, I guarantee you someone's going to go in there and try to start a robotics convention inside, right, the robotics service in one of these guys, right? Don't do that. Don't leave it wide open. The other piece is that you probably know what your data protection laws are, especially if you're dealing with a lot of like government work, depending on the government in question, right? Notice that if you have customers, for example, who are in the EU, GDPR, you know what your data governance policies and limitations are, or at least your team does, right? So obviously make sure you're complying with those depending on what your customers are and where your data is housed, right? That probably goes without saying. The Department of Defense, by the way, has the Cloud Computing Security Requirements Guide, which is it provides a standard assessment and authorization process for cloud providers, right? There's a bunch here. There's a management framework. There's a ports and protocols guidance, right? That are shared between the cloud service providers and customers. You've probably run into this already. By the way, these cloud providers have a crazy number of certifications. Let me just pull this up really quick. There we go. Let's see. Here we go. Compliance, right? They have a ridiculous number of compliances inside the industry. So you can actually visit their compliance resources to see like what they have on a per service basis. The other thing that's worth mentioning is that inside each of your accounts, there's actually this section called Artifact. There's a service called Artifact. And this is all the compliance reports, attestations, and everything else that AWS has for every single security certification that they have access to. This ranges from the 27001 ISO certification to FedRAMP customer packages, right? HKIA, right? GL20. There's a lot here. So if you ever want to get these, you can just click on it, say I want to download the report. There's 2 pages worth of reports in here. This, by the way, is global. So this includes APAC, EU, and North American certifications. So if you ever need to see the attestations or any alignment documents or any other kind of like evidence of findings, they're here. FedRAMP, which is the Federal Risk and Authorization Management Program, right? It's a government-wide program, usually a 1-to-1 certification. Amazon, Azure, Microsoft, Google, they all have that, right? With a variety of different of the governing bodies that make up FedRAMP. So that's covered. And then the other thing that's interesting, and this is what Booz Allen offers access to internally, is that all of them have a government version. Matter of fact, someone, I think it was confirming from a couple years ago, the CIA actually hired Amazon to create their own private cloud outside of GovCloud, right? Like for that. And of course, we've seen the all rigmarole around the JEDI contract and all that stuff with Microsoft and Amazon, right? My point being is that there are secure versions of these clouds that exist just for government clients, right? Much more stringent, much more physically isolated. Things are shrouded in a lot more obfuscation, right? During the sign-up process, by the way, you can't just get public access to this. You actually have to have a certifying review process to get into GovCloud. So AWS has GovCloud, for example, right? Oh, wow, that's a lot. Hold on, let's take a slow this down a little bit. Let's go through this. So AWS has GovCloud, right? Which has specific regulatory compliances, including FedRAMP, the DDSRG, the DoD SRG, Impact Level 5, Criminal Justice Services, right? You see ITAR requirements as well. ITAR, of course, comes up a lot, especially with aerospace. So they have GovCloud, which meets those particular requirements, has obviously some FIPS 140-2 approved cryptographic modules for API endpoints. You cannot access GovCloud with standard credentials. It's actually almost its own ecosystem, separate from public cloud, right? In addition, there's a bunch of privacy acts. Those are all in the artifact section of the public console. And there's a bunch of compliances, as you saw when we were looking through the attestations, right? Different SOC levels, different ISO levels, right? Of global compliance as well. Here's another set, including the listing of the ITAR, NIST, MPAA, SEC rules, VPAT. Azure, by the way, follows the same things. Or Azure, sorry, sometimes I mispronounce them. Microsoft does the same things, right? They've been running data centers for years. And so just like Google has, right? Probably even longer actually than Amazon, right? And so they have the same level of compliance, if not more in many cases. All listed here for your review, but includes the standards, including the criminal justice, FedRAMP, NIST, ITAR, etc. Google's the same way, right? Google doesn't have the fuller depth of certifications, but as I mentioned before, they're kind of behind on some things, but they do have quite a few. They don't have the fuller scope for their cloud compliance. But you need to do a specific review of the cloud provider to make sure it has the security clearance level attestations that you're looking for the service that you're using. So it's by cloud provider, by service. Not every service meets every level of like whatever HIPAA compliance or the CGIS compliance. You actually have to look at it on a by service level. So we skimmed through a few pieces around security to talk about some considerations, the full like crazy depth and breadth of security attestations or certifications that Amazon and Azure have in particular. Google's a fast follower on that, right? And just the fact that there are cloud adoption frameworks and a lot of enterprise literature about security and adoption frameworks for security in these cloud providers. Questions? If so, or sorry, if not, actually, we're on our last chapter. The other of the two harder topics inside of cloud, which is billing and procurement. Okay. Okay, so I'm not, you obviously know that you have a group that obviously manages cloud for you, right? But there's a central department that usually controls like billing. They want to know what the costs are, right? Et cetera, right? So this does, by the way, puts IT in kind of a central position of brokering cloud, right? Making every other, group inside the company, the customer, right? The first thing to know about billing inside of AWS is that you're shifting away from using capital funds on a depreciation schedule for hardware, software, including maintenance and whatever support, right? Versus using operational funds. That's one of the great benefits of cloud, right? Is that there's no more large capital outlay. So instead of spending $200,000 over the course of a year or 2 years, you're spending $10,000 a month or less, right? Depending on how efficient you are. And so you don't have to outlay these large capital expenditures. Now, in terms of billing and procurement planning, many organizations, right, have underestimated or even overestimated the amount that their migration is going to like cost. The truth of the matter is that most people underestimate how much they think they're going to spend in cloud, especially if they are not taking the time to be incredibly efficient and careful with their cloud consumption. By the way, that second point about avoid overbuilding, I'll just say this is that you can actually like make a big cloud and then shrink it based on what the actual usage is. So you don't want to stay overbuilt, but you can make large guesses and shrink them back. I have a great story for this. I actually was working for a company a couple years back, and they're like, we've got a brand new product. We think that we're going to have 6 million concurrent signed in users at the same time. By the way, the most they ever had was 60,000. But as the VP of operations, me and my team, we set up this massive infrastructure, and they ended up only having 60,000 clients for the first month. And it kind of doubled there, but it never got to the crazy numbers they were throwing at us. What do? We just gave back all the infrastructure. Within like 2 weeks, we're like, hey, we're not even close. So we're just going to, we're going to shrink it down. So you can actually overbuild. The great thing about using a cloud provider is that it's elastic. So you can just give it back, right? One thing, by the way, is that try to at least make everybody aware of projects and what you're doing or what you're about to spend, so people don't get blindsided or shocked that you've now gone in a different direction. Try to assess, pre-plan, and proof of concept your ideas in the cloud as early as possible so you can get accurate information about what it's actually going to cost. And by the way, that includes load testing and performance testing. If you're not doing that against your proof of concept, you don't even know if it works. Every single cloud, whether you write it yourself or use the homegrown solution, will have what's called a service catalog that allows you to pre-script or pre-template or pre-define certain services inside the cloud provider and make those available to your users in a very templated way. You can even have an approval workflow system that says, hey, if you want to start this, you need approval from your boss, and it will actually send a notification and say, hey, can this guy start 5 machines of this size at this cost? Sure, no problem, right? So just know, as it relates to billing and costing, you want to come up with a system that allows you to maintain visibility around cost, track costs, but also limit the scope of services that people can get access to. Financial tracking is so incredibly important with cloud. Why? Because it looks like you're going to be spending a lot of money, right? Relatively. How do you know whether or not you're getting maximum dollar for that? How do you know what project this particular build resource ties into? What if you're spending $50,000 a month on a particular project and you're getting $100,000 a month in revenue off of it? 50% of your cost is operational. Is that okay? So you got to track your costs really deeply. And by the way, just with AWS in particular and Azure, both of those two with the subscriptions, whereas Google will actually say create a project and then all the costs will be tied to that project. The other two, you probably need to create dedicated accounts and or tag your stuff for accounts or subscriptions. Tag your stuff, your virtual machines, your services, your other things, so that you can accurately do financial tracking. Tagging is incredibly important in that space. Sometimes, by the way, you will pay for things and you can figure out what its cost is because you're actually asking for a set of capacity. And sometimes you'll say, look, I want to pay per run. And it's only going to be pennies per run, but it's really like a metered versus an allocated resource. Meaning if you ask for a virtual machine and it's got 2 processors and 8 gigs of RAM, and you only use 50% of that virtual machine, well, your ROI is 50%. So if you pay $2 an hour for that thing, you're only getting about $1 an hour worth of usage. Let's say, compare that to say serverless, where it's only going to cost you like 0.00006 cents per run of an application function, but you run it 1 billion times. Next thing you know, you're spending $10,000 a month. It might be worth it. The value might be there, but you're going to have to pay attention to when you're actually asking for capacity that has a utilization metric to it versus when you're running a service that just like runs in a series, right? Allocated resources where you actually ask for capacity, not just utilization, is standard for private data centers. Whoops. So make sure that in addition to having some tagging system to tracking your financial tracking, that you're painfully aware of like when you're asking for capacity versus when you're actually asking to use something. Virtual machines are allocated capacity. Metered means that you're actually using it when the thing is actually used. It's not, it is the actual utilization of the service. All of the providers have awesome billing reports. They have budget alarms. They have notifications. You can break it down by region, data center, service. All of them will allow you to see not only what you've spent, but in many cases, they will be able to forecast what you're going to spend that month based on what you're spending right now, right? So you actually get forecasting on some of these systems, right? So you can see which services are being heavily utilized. You can see which are left running, but they're not in use, meaning they're being wasted, right? So you've got to have a billing, auditing, and assessment strategy as part of your consumption of a public cloud. So billing reports are key for that. Getting them on a daily, if not weekly, if not monthly basis is essential. I have been, by the way, involved in what they call drawdown accounts, where, for example, you go to Microsoft and you say, look, I want to spend $5 million with you for the year, and I want you to just draw off of that, and anything that's extra just roll over to the next year, right? Or if I go above that, you're going to give me a huge discount because I've met my minimum spend level with you, right? So yeah. So just know that sometimes people have done that. I've only seen that with Microsoft. I don't think Amazon even does that, by the way. I don't know if Google does either. Huh. This I've unfortunately seen quite a bit. I actually had a customer, by the way, who didn't pay their AWS bill for 8 months. They owed Amazon, I want to say it's like $1.1 million or something like that. Amazon was so nice to them, put them on a payment plan, did all this stuff for them. Then they didn't pay the payment plan. And then finally, after like, I don't want to say 9-10 months after they missed that first or second payment, Amazon locked their account. They lost their entire infrastructure. After Amazon repeatedly talked to them, like worked with them, it was like, and I thought Amazon did a great job. I mean, can you imagine owing somebody 1.1? I mean, that may be small change in the enterprise world, right? But I was just like, and they really bent over backwards. They even called me because I was formerly there at one point in time, and they were like, hey, these guys can any way we can get them to talk to us. We want to come up with a payment plan. They were so nice about it. And it was so odd because like company just refused. They weren't going to do it, right? There were trouble, issues, whatever. So most of them, by the way, have grace periods that last for a long time. But, you know, just to say this, these providers are going to be holding most of your data. They're not going to do anything malicious with it. Don't read into that, right? But they're going to close your account, right? So, you know, just talk to them if you run into problems, right? But what they did is they paused services and said, look, if you pay us some money, we'll actually open it back up, right? So most of them are super gracious. They don't want a bad reputation. They don't want to be a bully. They're not trying to take advantage of you. They're certainly not going to keep your data and do anything with it, right? They're just going to close your account. So I have run into that one time, major time at least. So obviously, you know, you're going to have a way of reconciling with Booz Allen in particular. You've already got these systems in question, right? To reconcile how spend in cloud should come back to a project. I'm not saying it's not complicated. I'm not saying it's not crazy, but you probably already have a process or system to do this. It's probably not the most awesome thing in the world. It's probably actually extremely boring, but it is required, right? Last few slides here talking about legal and contractual agreements, right? Most of the time there'll be an SLA, but they won't necessarily give you any kind of financial remuneration, right? Per se. If you're in an enterprise contract with a cloud provider, there will be clauses typically about financial remuneration if there is a service outage, right? By the way, we keep contracts and legal agreements for when things go wrong. So if you're involved in this level, make sure that you are thinking of like what could go wrong and what you need in order to like take care of the company, right? That includes, by the way, migration terms, transaction fees, liability, maintenance windows, right? All of that is typically controlled by you. And so it's not really a limiting consideration from a provider standpoint. I think I mentioned this before, especially when it comes to billing. A lot of the legacy like software providers don't have great licensing for cloud. And some of the like data store vendors don't like cloud at all. And so there's kind of a little bit of a fight between licensing, like Elasticsearch or MongoDB, for an example, is having a little bit of a tiff with some of the cloud providers about offering their open source software as a service. And so make sure you check the licensing. There could be hidden costs in there. There could be hidden limitations in there as well. There's typically not any licensing restrictions on AWS or Microsoft or Google side. It's usually when it's like third party outside of the cloud providers. That's when you're going to run into challenges. Sometimes, by the way, the licensing is cool. Like if you buy Windows Server from Microsoft and you have an enterprise agreement, you'll get free Azure virtual machines workloads as a result of buying those agreements. I sometimes suspect it's like ways in which Azure like pumps its numbers, because every time you buy a Windows Server license, you actually get a free workload in Azure. So I sometimes wonder like what they're doing with that statistic. So sometimes the licensing works in your favor. Most of the time it doesn't. I'm sorry, most of the time there's no problem with licensing. If there is something different about it, it's usually not going to work in your favor. Occasionally it does actually work in your favor. Okay. So a few things to note here. One, cloud services focus on OpEx, not CapEx. It's not about capital or hardware expenditure, right? When you are acquiring hardware and software, particularly for your private cloud, obviously don't over provision. If it's for your public cloud, yep, I lost you for a second. Don't worry, I noticed it and I stopped talking. Good. Not sure what that was. Okay, so cloud services involve OpEx, not CapEx. Make sure when you buy hardware for your data center, you try to be as lean as possible. But for cloud, you can over provision and then right size it. Make sure you involve a bunch of people. Remember, it would be better to get agreement from everybody around spend and security and all these other pieces, but get them on board early in the cloud planning process, right? Instead of later. Remember that if you do an approval workflow, don't have too many steps, but make sure you scope and template what your offering is, because that will also help you with costs, right? You don't want people spinning up quantum computing instances. That's not going to make any sense. And then remember that fixed pricing is more predictable. Variable pricing can go high or low. So make sure that when you're looking at getting things, that you are scoping things appropriately for an average level, but also like look at services where you can buy things in chunks. Like you might, by the way, buy 100 virtual machines and say, I want these for a year, and then have some variability based on burstability in your cloud provider, right? So focus more on buying things in like blocks than like buying services that have a high degree of variability to them. Bottom line, the thing you should take away from this is that billing done properly requires you to track it just like you track your checkbook in your accounts, right? You need to tag things properly. You need to know what projects your resources are assigned to. And so everything that gets started needs to be tagged. So to really do billing well, you have to have a great tagging strategy, regardless of the cloud provider. Regular audits to reconcile what was spent against what was billed is probably a great practice. And so get to know and work with your financial auditing division to make sure that your project has been scoped appropriately, particularly as it relates to public cloud providers. Try to be as elastic as you can with public cloud in particular, because if you do that, you can stay just a little bit ahead of customer demand instead of really ahead of customer demand, and then you have a bunch of waste, right? Customer demand is going to go up and down. You're going to follow it by just staying a little bit ahead. Auto scaling in all forms, scale sets on VMware are your friend. VMware scale sets in Microsoft Azure is your friend, but try to use things that stay with customer demand and just ahead of it, instead of buying large chunks of capacity and then having customer demand vary inside of it. That's not going to work. And keep refining and adjusting your model. Look at how you're spending. Look at using SaaS services, right? Look and refine what you're doing. And of course, always look at your licensing and your SLAs, because there could be hidden pros and hidden cons in them as well. So here's some other kind of like summations, right? Remember, this is OpEx. Avoid overbuilding in your private, but overbuild in public, no problem. Just right size it. Evaluate fixed fee and variable fee services and make sure that you're using the right one. Prefer services that are actually scale with your demand instead of provisioning services that require you to buy chunks. and then try your best to make reviewing your billing and accounting data a regular practice for your project so you can maintain efficiency and leanness. Okay. What did we talk about? Well, what we talked about was that we went through everything regarding general cloud computing, talking about the characteristics of cloud, self-provisioning, large network pipes, etc. We talked about things about the models about infrastructure as a service, platform as a service, software as a service. We talked about public versus private versus hybrid, and we talked about the ephemeral community cloud. We talked about how basically cloud enabled DevOps because it's now software-defined infrastructure. And that the old models and ways of taking that you've managed your data center from a people, process, and technology standpoint are not the same ways that you want to move into cloud with. And that security and billing are the harder topics in cloud. And so you want to like reassess your security models and reassess your billing models, including your tagging strategies, to understand the impact of billing and the impact against security, right? When it comes to public cloud providers. Now, the cloud providers themselves have a huge swath of services, everything from quantum computing to your basic virtual machines, and that there are distinct differences between the providers, but for the most part, they're kind of like closing in on homogenization. Remember that AWS tends to have the most features and services, great stability, a little bit more expensive. Azure has a great developer experience, very well known in the community, great hybrid offerings. They tend to be a little bit less reliable and about middle in the services and the reliability tier. Middle, they tend to be bottom in the reliability tier. And then Google also focuses on developer experience, has a smaller set of services, but they're very reliable, really great at what they do, but they just don't have the breadth, and they end up being the cheapest at the most value for the services that you pay for. And then when you think about what it takes to migrate to the cloud, consider your people, processes, and technology, but as it relates to application modernization, think about one, whether it's just worth it to just kind of cut the application off and replace it with a new one in the cloud, right? Just completely replace it. Whether it's worth evolutionary models with your application, whether you can just lift and shift it, whether you want to lift, tinker with it and shift it, whether you want to lift it and refactor it and make it a new application in the cloud, or whether you just want to keep it wherever it's at, retain it, don't make any changes to it because you're getting the value that you need from it and there's no reason to move it to cloud. Cloud's not a panacea, right? You use cloud when you need cloud, but I will say that in today's 2021 infrastructure, cloud is an afterthought. It is a mainstream here to stay platform that almost everybody is using, but you may not stay there. As you become more and more sophisticated with technology, you might end up moving to more of a hybrid model with cloud. And that's it. That's my review of everything from public cloud to securing cloud to billing in cloud to application modernization. And it is 3:20. So I'm opening the floor up for any questions, anything you might want to ask me. We're not in a rush to leave. We got at least 10 more minutes. But I wanted to open the floor if anybody had anything they wanted to talk about. Or if you want to do an interpretive eye stance of your career, I am still recording. I would love to see that. So, Adam, where can we get the recording of the class? My understanding is that the recording will be emailed to you. It's not done yet, so I can post it. Yeah. Good. Other questions?
Hey, Michael, this is Rachel. I work in contracts, so I don't have a computer science background at all. Could you briefly explain how cloud works exactly?
Yeah, so the way the cloud works, briefly, is that previously before, we had a data center that was full of a bunch of physical objects, servers, networking equipment, storage equipment. So like when we went to go to a website, we went to type in like www.cnn.com, what would happen is that it would resolve to a bunch of servers on the back end that were all running web server software. And that's how CNN would show up in our web browser, right? Is that we're hitting CNN's data center and they got a bunch of servers in there. And in those servers, they got networking and storage and all the things necessary to run a server. And that's how we would traditionally run a data center. With AWS or Microsoft's Azure or Google, what they've done is they also are running a data center, but here's the difference. Instead of CNN having to physically manage all of that hardware and the networking and the cooling and running a location and making sure that everything points to all these hardware objects, what we're doing now is we're taking and basically allowing someone else to manage all of those objects, all the servers, all the software on the servers for the most part, and we're allowing them to manage it for us. And the only thing that we're doing is putting a credit card down and saying, can I get programmatic access to manipulate these objects? That's all we've done, is we've taken the business of running data centers with servers and all these other applications in them, and we've given them to somebody else and said, look, I will pay you on a per server, per service basis if you'll just let me configure the service and run a website, but I don't want to have to manage the hardware or the data center in any way, shape, or form. That's basically what we've done with the cloud providers, is we have outsourced running all this hardware and given it to somebody else. Now, it's a lot more advanced than that because hardware is the coarsest level of outsourcing. We're also now outsourcing things like databases, and we're outsourcing things like web servers, and we're outsourcing running of code, right? But that's what we're doing now, is we're basically allowing someone else, right, to actually run our data centers.
Okay. That's a lot more simple than I thought it was.
Yeah. The difference is now we can get access to that, but we actually do it through like programmatically, like using code. We don't have to go in there and run cables and turn on servers. We don't have to do any of that anymore. We just run code, and that code looks to us like it's in a data center doing something, right?
Okay.
But we don't have to touch it. We don't touch hardware anymore. That's the simplest explanation.
Yeah, I appreciate it. Thank you.
Yeah, you're welcome. Thank you for asking. Let's see, Adam, he's like, I get IaaS and SaaS, but I'm not clear on PaaS. Let's talk about that. So is there a great, there was a great picture somewhere in here. Oh, where was it? I don't know my own slides. Anyway, I'll talk about this for a second. All right, so Adam, here's the difference. Infrastructure as a service is kind of like what I just described to Rachel. It's just that raw data center, right? Meaning I'm running virtual machines. Excuse me, my nose is itchy. I'm running virtual machines, and I just want access to virtual machines, or I might want some networking components, or I might want some storage components. And that's just raw infrastructure as a service. Software as a service is like, I go to www.gmail.com and I log in, and I don't care what servers are running it. I don't care about the software. You know what I want? I want that web page to load, and I want it to accept email. That's it. That's a high level software as a service. So I can see why you might get those two, because it's like, oh, I get that. That makes total sense. Now, here's where the difference is. Platform as a service is when you're running an infrastructure piece of software that actually does something, like, for example, a database. A database is not an operating system running on a piece of hardware, and a database is not necessarily a high-level consumer service. It's like a middle service, because it's an application that feeds data to other applications. That's a platform, right? Meaning a consumer is not going to come in and be like, you know what, I really would like to run my email on top of this data. It's not going to happen. What's happening is that you didn't ask for the low-level operating system. You didn't ask for an application output at the top. What you asked for was a platform that fed out data. You might ask for a platform that feeds out APIs. But this isn't a high-level abstraction. You can actually go into that software and turn the dials on it. You can't go into Gmail, for example, and actually change the way the mail servers function. You can only modify your experience, your particular profile on top of the application. But with a platform as a service, you get access to an application and you can change and turn the dials on how the application functions. With infrastructure as a service, operating system is what you get to change. Platform as a service, yeah, it's a sandbox. It's exactly right. That database, if you request a database from say like Google or whatever, it's actually in a sandbox. You can't even touch the operating system and you're not running anything high level on top of it. You're actually messing and turning the dials on the database, but it's not an abstraction. You actually can see the software and turn the dials on the software. Whereas if it was database and it was a SaaS, you would get a web page where you could like see the data and manipulate the data, but you couldn't touch the database application. You would just consume the data through a website, right? And that's typically how we run SaaS. SaaS is typically fed to us through a website interface or a mobile interface. And that's the difference. If you can touch the app, it's probably a platform. If you can touch the operating system, it's going to be an infrastructure service. Hope that was clear. Okay. Yeah, you're welcome. All right. Other questions? Those are good ones. All right. Well, thank you for coming to the presentation today. You will get an email afterwards that contains the recording. You should have already gotten an email that has the link. Typically, when they send the recording, they'll resend the student link just so you can have the slides. You might also see in there an evaluation. I say might, you most likely will. If you can, please fill that out if you get a chance, if you want to see other topics, or if you feel like that I was rude, crude, and socially unacceptable, or you were really disappointed that I didn't do an interpretive I stance of my career, you can put that in the evaluation as well. I'm Michael Forrester here for WebH Solutions. I'm going to linger just in case anybody else has any private questions, but we are officially done and closed. Thank you for coming and listening to me talk. I hope you learned something, and we'll catch you next time. You'll see me a lot for Booz Allen Hamilton. So have a good one.
Thank you.
Michael, thank you so much. It was very informative.
Awesome.
Thank you.
Thank you. Thank you.